I gave it to Jurgen. He has it. So you need it. Yep. Sorry, that.
No worries.
I was just going to put it up there anyway.
I assume so.
Good morning, everyone. Come on. Good morning, everyone. Thank you. Good. We fed you good coffee. Welcome to Google. In particular, welcome to Google Cambridge. My name is Yvette Namath, and I am actually not from Google Cambridge. I am from our Seattle office. Just a quick hi from me, because I will be with you the next 2 days, helping figure out what's going on here. I've been with Google for about 9 years now, spanning both products in ads and maps. I'm a test engineer and a manager in the Seattle office for the Google Maps products right now. And I don't know if you can tell, but I'm rapidly losing my voice, so I'm going to try and keep this sweet and informational. As some of you in the audience may know, that might be a little hard for me, but I'll do my best. So first of all, let's make sure you know where things are. One of the most important things to know where it is the agenda. What are we doing over the next 2 days? When are things happening? All of the information, such as agenda, how to submit questions, how to view the recordings after GTAC is over, are available on developers.google.com/GTAC. So just go there to find the link for all questions, which speaking of, it also contains the link to the live stream. Welcome to everyone viewing on the live stream, which is going on right now. If you're in the room with me here, remember, you might actually be on camera. We've got signs all over the place telling you that, but this is my one last reminder. The world might see you for all posterity. They're going to see me for all posterity. I'm sorry. So it is what it is. And that information is on the website. But the other interesting piece of information for those of you in the room and those of you on the live stream is that our links to Q&A are also available from that same website. So again, you go to developers.google.com/GTAC, and you can find all the information on how, the link for this, our way of asking questions. For every talk, what will happen at the beginning of the talk, it will show up on this site, the same site for every talk. There will be the date, time, and name of talk, and you enter your question. At the end of the talk, assuming there's time remaining, we will take as many questions as we can. And if somebody has already asked your question, feel free to upvote it. We'll be taking the top N questions for every talk. Another logistical piece of information, because I got the exciting stuff, the really meaty stuff. Please wear your conference badge at all times. This is our way of letting physical security know that you are legit to be inside the building with us, that you are a Google guest. And this same badge is what will get you back into the building tomorrow. So without it, I'm sorry, you'll be one of the live stream participants from your hotel room, and that would be really sad. So please wear it. You will notice one particular thing about your badges. Most of you have like white string lanyards. There will be a few people around who have a black lanyard on. The black lanyard is very, very special. These are your buddies should anything not be available to you on the website or obvious from what I'm telling you today. These are all the organization committee people, and they will connect you with whatever answers you need here. There's another special colored lanyard that I'd like to call out, though, too. That is the blue lanyard, and that is all the speakers over the next 2 days. So just thank them for donating their time to speak. Of course, there's this thing called social media. Regardless of what platform you use, we'd love it if we could coordinate a hashtag, because we're like that. GTAC 2015, when you're posting on Google+, Twitter, Facebook, what have you, Instagram, any of the above. We love to see your pictures. We love to hear what things are really standing out, what new questions you have for yourself, what memorable quotes you heard the speakers say, etc. So please share those with us. Well, you're at Google, and I think everyone at this point knows that Google has a lot of free food around, and we're not going to leave you out of this. Lunch is provided on-site by Google for you each day. You really don't have to go far. I think one of the stations will be just as close as breakfast was to this room, but lunch will actually be available out in the common area just outside of this room, as well as there's a common area upstairs that requires no badge to get to other than your conference badge, where there will actually be tabled seating for you to sit down. It will be different each day. There are vegetarian, omnivore, carnivore options available to you each day. So welcome to Google and enjoy the food. But we're not done there. We've got tomorrow, and we've got to recharge. So tonight, Google Recruiting has decided to help us out by sponsoring a casino night. No real money involved, funny money only. Dinner, drinks, games, poker, roulette, Texas Hold'em. Come, have fun. And again, it will be in our wonderful shared space here in Google Cambridge. Now, there are some changes that have happened over the years with GTAC. One of the biggest changes that has happened over the years is that we've started to expand. We've expanded the types of technologies that we talk about here at GTAC. We now not only talk about software testing and explicitly web testing, we talk about app testing, phone testing, testing machines, testing with robots, accessibility testing, you name it, we talk about it. But with that, we've actually increased our diversity too. And we wanted to actually explicitly recognize that this year. And one of the changes that we've made this year is actually calling out explicitly our diversity policy on the website, as well as our code of conduct, which you've seen on the website, posted around this conference space and here on the slide. I just want everyone to keep in mind this notion of inclusiveness when having lively discussions with your fellow tester comrades here at GTAC and when asking questions. And if you have any questions, feel free to bring it up. Talk about what does this actually mean? What does this imply? This is another interesting conversation we can have here at GTAC. With that being said, let's actually talk about you guys. This is a wonderfully diverse group of people in front of me, and those of you on the live stream who didn't actually get to come join us today. So we had 1,362 applications to actually attend GTAC. That's an insane number. Just look around if you're sitting in the room with me, and how many people do you actually think are here? Just a few hundred. We had approximately 200 applications for speaker submissions, from which we picked only 24 talks. And we had over 250 Googlers apply to attend, let alone the others that just showed up. There are tons of you here, and we thank you for wanting to come, for making our job so hard when we were doing speaker selection that we actually followed our own advice. We really wanted to take diversity into account this year, and rather than just looking at the diversity of talks, we took into account the way Google has been promoting the notion of unconscious bias and recognizing when unconscious bias comes into the workplace. And in this vein, we actually removed all PII, personally identifiable information, during the speaker selection process so that we could really focus on what you're talking about and make sure that we get a good breadth of technical talks covering all sorts of things. Additionally, we actually added one more thing that came out of the feedback from last year. We're Googlers. We live in this beautiful Google bubble with massage tables and food and infrastructure that some of you would drool over. But that's not necessarily representative either when we're doing selections. So for the first time, we experimented with having somebody who is not a Googler on our speaker selection committee. And we'd like to thank Vishal Arora, who is not actually here with us, but who did dial in and give feedback on the entire speaker selection process and helped us make it a better conference by pointing out where our unconscious biases, because of our day-to-day infrastructure challenges, where they were coming out in our speaker selection and even in our technical selection. So that was kind of cool. We ended up coming out with 5 academic speakers, 8 Google speakers, and the rest are everyone else, showing us as broad of a range as possible. I gave you a little snippet of where people are from up on the slide. However, let's make sure you're really awake. That welcome sounded pretty good, so I'm hopeful. So I'm going to play a little game with you. I would like anyone who traveled more than 20 hours to get to GTAC here in Cambridge to please stand up. Stand up. Thank you. I think these guys actually deserve a round of applause. No, stay standing, because you're eligible for the next 2. Now, come on. Some of us traveled more than 10 hours. Stand up, please. If you've traveled more than 20, you've traveled more than 10. Stay up there. Okay, yes, we're getting more. Did you travel more than 5 hours? This is where I get to stand up. Did you travel more than an hour? Let's get New York City standing. Okay, if you have any neighbors sitting down, say hello to the locals. They're your tour guides for the next few days. Go make a friend. Thank you, everyone. You can sit down. With that being said, I want to tell you a little bit about what it is like to be local to Google Cambridge. This office has over 900 Googlers across 12 floors and 3 interconnected buildings. It wasn't always this way. When I first visited Google Cambridge, there were less than 50 Googlers here about 6 years ago, maybe more. I don't remember. It is actually the second largest office east of the Mississippi, the other one being New York City. It started out in 2003 as a small sales office, as many of our engineering offices did. And then, of course, engineers were like, we want to work there too. That's a great location. It was actually in Boston and relocated to Cambridge in 2006, and this particular site opened in 2008. I listed a bunch of the projects that exist in Google Cambridge, but with a 900-person office, we have a really good cross-section of the Google product space. Everything from internal tools to ads latency to Chrome, Google Play. ITA is one of our particularly unique projects here, etc. And you may notice, and you'll really notice if you go on one of the tours, which I'll tell you about in a second, that this office has a theme, and the entire office is themed like the T. So each building has its own color. I can't remember what color we're in right now. I think we're actually in the connector, so we're in one of the connector colors. But each building has a color, and there are like subway-like maps for getting around the buildings because they don't actually connect from floor 3 to floor 3. You may end up going from floor 3 to floor 4. So it's kind of important to look at your subway map to get around Google Cambridge. And if you actually want to see this yourself and see the amazing office space along with the green space that you may see outside the windows just outside this common area, we are offering tours both today and tomorrow at 1 p.m. and 3:30 p.m. You can sign up during breaks or lunch just outside near where you picked up your swag. And for people on the live stream, I'm sorry, look at pictures online. They're great. And we hope you can join us at whatever our next location may be. How am I doing on time, Matt? I have one other thing. I'm not supposed to talk a lot, but I can't help it. Oh, the slides didn't reload. I'm not supposed to talk a lot, but I really can't help it. I wasn't even sure I could talk about this morning. But as of 9 a.m. Eastern time today, a product I have been testing in secret for the past 2 years finally launched. It's the first time I actually got to launch a product that people didn't know about. You don't even know what it is. So as I'm standing here speaking with you, my team is having mimosas because we just actually launched offline Google Maps for mobile. Meaning now you can do searching. Yes, you're my hero, AV. You can now search for a restaurant in a location where you've downloaded your map, regardless of whether you have internet connection. So long as you have GPS, which does not require Wi-Fi or data signal, you can navigate to your route using turn-by-turn navigation in locations. So this will be rolling out to GMM on your phone, GMM Google Maps for mobile. Sometime soon, we're doing a slow rollout, but it is now out there in the wild. So that's really awesome. But guess what? I spent the past 2 weeks debugging a test that was really, really annoying. I had this test where on every emulator I ran it on every phone I ran it on, when I stepped through it, it would not reproduce the behavior. It would not allow me to select an area to download. I was like, what in the world is going on here? I can do this on my emulators, regardless of my API level. It doesn't matter what version of Maps for Mobile I'm actually running. This is like consistent back a few versions of our dev build. What is going on here? Turns out I uncovered one of those bugs that our users probably never will, that only my automation could. Once upon a time, a developer assumed that your finger would be on the screen when you hit that particular screen where you select areas to input, and that's what triggers the, is this area valid to download? And I was using automation to trigger this, meaning that there was no interaction with the device, and every time my test was failing. I spent 2 weeks on this. That's embarrassingly long. Like, let me tell you. Although kind of funny. Like, let's be honest, the team would walk by and be like, did you get it yet? And I'd be like, seriously? Are you asking me that? Do you really want to ruin my day? But In the end, I just want to remind everyone, we're going to hear about a lot of people's successes, whether it's launching offline Google Maps or whether it's spending 2 weeks on a ridiculous edge case bug that's a huge challenge. And these come hand in hand. With every challenge, hopefully a few of those put together will result in a success. And with every success, ask the person, what challenges did you learn from along the way that helped you get here, so that we can learn from each other. So I'm just going to actually put out a challenge to you guys to say, what helped you get here? And congratulations on all your big successes. And with that, I'm going to actually hand over the mic, well, the clicker, really, to Jürgen Alger of YouTube to talk about testing on the tube.
Whoever designed this needs to hand out, boy, there's an echo too. Not only do I need sunglasses, I need to get used to my new voice here. Good morning, everyone. Jürgen Alger, that's me. I run the test group in YouTube. And over the next, what's left, 15 minutes, I'm going to give you an overview of what challenges we tackled over the last years and our success story, at least a few of them. I joined Google 8 years ago with a job to build up the engineering productivity function in Europe. Probably most of you have heard about engineering productivity in Google. It's an umbrella function for lots of disciplines all around testing, automation in general, speeding things up, from speed up the compilers all the way up to building tools to help find maybe those bugs that take 2 weeks to find manually. When I heard about this idea of building an organization really only focused on that, I was very intrigued, applied for the job, got the job, moved to Zurich in Switzerland, and for the next 3 years started to build up this group. And then I got a repeat offer to do the same thing for YouTube about three and a half years ago. And again, it was pretty interesting to see, okay, for coming from the world of trying to do this operation across all of the different product groups within Google that happened to be in Europe, in one of the Europe offices, kind of pivot around to say, okay, wherever a YouTube team works, which is Zurich here, San Bruno in California, Mountain View, of course, the home base, LA, Paris. Wherever we have people in YouTube, I helped build up this organization that hopefully helps us to get YouTube and the operations behind it clicking on all cylinders. So what I'm going to do in the next time here, in the next hour, is to lead you through a couple of those challenges that we were facing. But let me first give you a bit of an introduction into what this system under test we're going to talk about actually looks like. Yes, we're going to talk about YouTube and pretty much only about YouTube. So I will not mention a lot of other of the product areas and tools built there. I'll just give you the story of the smaller scope. As it's not really surprising, being a video service, a lot of the stack is built up with proper video services, how to upload, how to transform, how to get all the different formats in, how to stream out, how to distribute over the data centers, et cetera, et cetera. On top of that, we have a set of very unique features that differentiate YouTube from the other services that are out there. When I joined, we had our main site, youtube.com, and we're just starting to build the main YouTube app for Android and iPhone. But over time, in the last 3 years, this has changed as well. There's many more apps. We call them verticals that we'll talk about a bit more. And of course, we have all the platform metrics, right? So for the main site, all the browser combinations you are well familiar with. And then with the apps, then we got a lot of interesting platforms that are not in the typical mix. So YouTube runs on TVs, on set-top boxes, on PlayStations, right? So unfortunately, in some of those, we are not as far along in automation terms. And I really would want to reach out to you, anyone familiar with that type of problems and working on that, please reach out to me after this. I'm really interested to learn about how to automate on a TV, for example. One step deeper into the details, as I said, video service. So we are concerned with getting your videos up, be that from the desktop or from mobile. We started streaming live from game stations, where the gamers can stream up live. We have live streaming. You might remember the big Olympics streaming through YouTube a few years ago. So we get the stuff in, lots and lots of pixels and bytes. We start processing. The processing typically happens within 3 minutes, and in that time, we get the formats converted. We are still in the mode of pre-converting, so we convert an upload so that when you request the video, we are actually ready to serve out the format that you need. We store it, obviously, and distribute it through the centers. Later on, the streaming component helps to get all of these previously generated formats out in the various platforms and device formats. You probably heard about our adaptive streaming, where depending on the network speed and the quality of the network you're on, you might change the resolution and the quality of the stream that comes in so that you on the device get the best possible experience without seeing the spinner too much, hopefully. So around all this, on top of that, we have some very special things that not everyone knows about or recognizes right away when you hear YouTube. The biggest unique differentiator between YouTube as a video platform and most of the others is that we have this feature called Content ID, a way to allow creators to protect their content on YouTube by using or utilizing the information about the copyrights they already have. Right? So you upload your video, you do something we call claim, so you call out that this is yours and you don't want to share this with anyone, and that any usage rights you should be in control of, et cetera, et cetera. Interesting part of this is that these copyright rights are handed out by territories. So meaning if you own a video that has 4 or 5 copyrights for lyrics and live performance and digital streaming, et cetera, et cetera. If you have those, say, in the US, it's not necessarily true that you also have those in other countries. If you travel a lot and you use YouTube while you're traveling, you may have seen this video not available in whatever country you happen to be in, although you just yesterday watched it before you entered the plane, right? And this is why. So the owner of the video has managed to get the copyright in the US, has not managed to get it somewhere else. But overall, the content is protected. So when we look at this and try to stream this, we say, OK, until this is resolved, sorry, we can't help you on. So that is, I think, the biggest differentiator to others, and brings a lot of people that create content, like musicians, artists, to stick with our platform. Next to that, we have a social components. You can comment on the videos. You can interact with your fans, for example, if you're a musician. And it's a pretty high traffic social component in that. You have personalization. You may have recognized that you get recommended videos. If you watch a certain set of videos, you get others that you think you might be interested in. That is based on a personalization engine that learns from your behavior. We have one of the larger search components that are out there. When I checked this beginning of the year, we were number 2, so we're still probably pretty high up there. The search is obviously optimized for video media. So if you put the same search into google.com and into youtube.com, you will get different results. because in our site, you get videos and not news reports and other things. Right? I mentioned the platforms we're on. It's pretty much anywhere you can think of, with some trouble spots, like I mentioned the TVs and set-top boxes. A variety of browsers, a variety of versions of Android. You may have heard that we have more than one out there. A bit fewer on iOS, but still a variety there as well. So we have the usual matrix of testing and compatibility. There's also an aspect, and we move on to really the user interface, the client side. There is the challenge to keep in sync those clients with all the changes that happen on the mid-tier that are pushed on a pretty frequent basis, etc. We started out with just browser, as I mentioned, and by now we not only have what was on the browser before on the mobile platforms in our YouTube app, but we also diversified and have now more apps next to each other. Right? We call them the verticals. One vertical that was pretty popular through this year was music. We launched a music app where you get an optimized access through the interface, optimized access to the subset of the corpus that is music related. We have a special app for kids that has a very unique UI. If you ever looked at this, it's very different. Obviously targeted for kids, for young people. A lot of parental control in that. A lot of restrictions, a lot of scrutiny. Just recently, we launched our gaming app that, again, has the same idea, right? Just provide a very unique access to a subset of the corpus. And the gamers seem to love it. So talking a bit about what this engine actually does, what this machine actually does. If you have right now, we're looking at about 300 hours of uploads per minute. So all of these now in a huge amount coming from mobile. All of these videos come in about a dozen formats. We transpose them, we store them, etc. We have acquired quite a bit of corpus by now. It's in the billions of videos. And of course, there's this, if you say, talk of the long tail. If you say users over how many videos they actually upload, right? There's only a few that have thousands of them. And then there's lots and lots who have 1 or 2 or 3. Some of them uploaded, never watched. But still, they're in the corpus. We store them, we replicate them, we move them. Lots of fun. Streaming, you've heard maybe about some of the highlights. We had the Olympics a few years ago. We had the space jump. That was our peak outbound stream of several terabytes per second. So we have lots of users that use consume the media. We bridged the 50% mark, or we stepped over the 50% mark of mobile usage, something I personally couldn't imagine to happen. But we have half of the traffic now coming from mobile devices, right? So half of all videos are watched and consumed not on the desktop. What also is interesting is that kind of a little subsystem that's humming up there is that as you go to the site and you see the videos, you always get these little thumbnails next to the videos, right? Which is basically an image server that serves about 2 million images per second. Just noteworthy, I thought. I talked a bit about the content system. So we have lots of people who use that. We call them our partners. More than 8,000 individuals or groups that make use of that, make quite a bit of money with that. And we paid out, this is a number of last year, we paid out over $1 billion to those owners and rights holders. So this is the system I'm living in. And what we are going to talk about a bit in the next half hour probably is some of the things that I ran in the last 3 years and that we tackled and actually solved. Or let's say some of them we are still in the phase of solving them, in the process of solving them. I don't think any of these you're not familiar with. You've all heard those. Everyone has their own solutions to this. I hope this will be some insight in this. The first topic is what you do in an area where your launches are just not clicking along the clock as you want them to. Right? Some take longer, some go okay, but you can't really for sure predict, okay, tomorrow or in 3 days or whatever your schedule is, that you will actually hit the clock and your launch is ready. The second is a bit about our mobile device landscape. I mentioned that already, so a bit more detail there. And the third one is not a technical or tooling question, although we also try to solve this in a tool-based approach. How do you change a team's development culture from very fast, almost startup-like, into a more mature, process-oriented, quality-oriented team without losing the speed and iteration speed that you have in the startup phase? All right, up first. So here we were a few years ago having a very simple idea, or at least an idea that sounded pretty simple on paper. After we upload and the initial store of the video that you send us, we create lots and lots of formats, and then we store it. And I already mentioned some of them are never watched, right? So pretty straightforward idea is to say, well, why don't we transform them when we stream them? And we know actually at least there's at least one request for it, right? And then we start transforming, and then we start storing, and we go on from there. We could save probably lots of storage space. We could probably space lots of processing time during upload, so your video might be ready earlier. Sounded like there is not that many negative points to this, negative things to this. So we came up with an idea that we call on-the-fly transcoding, which means exactly that. On request, you start, and then you stream out. Lots of changes, some really video-specific technical challenges. But what I want to talk about is this. Don't worry, there's no test on this. Just trying to give you an idea of a system that has lots of components, some dependencies in between them, nothing new. What made it hard was these components were distributed over a set of offices. And you see these little lines showing through the boxes. So there were dependencies between components owned in different sites. So communication was a problem. Complete independence of ownership of the component was a bit of a problem. That was one dimension. The second dimension was when we looked at how these components are actually built and made ready to launch, so how the corresponding binaries were created, we found a picture that, again, had, some locally at least contained releases, but there's more than one, which means, again, now you see the lines between the release binaries. We have dependencies on not only content, but now also on schedule, right? So when our front end wants to push, and the mid-tier, the storage, say, is not quite ready, then what do we do, right? No surprise in what that resulted in, right? Everyone has seen these pictures. We start coding. We get a release finally ready and put it in an area where others can access it, right? So the other guy comes in, puts in his code, starts to bring it together, and didn't think of that. Okay, have to go back. While I'm going back and do some fixes, the third component comes in, right? So we're getting through the typical waterfall model of building large systems, right? And I think there's one more explosion there, yeah. This is when we wanted to launch, or a few days after, right? So everyone has seen these pictures, right? The problem was, okay, how do we do this, right? We have the need, obviously, for something that can be used in all the environments that we use in development. So that is my own workstation, kind of my local development environment. That is any staging testing environment that we build up, where others are already participating or I build up. And obviously, finally, it has to work in real life, what we call Borg out there. We wanted to make sure that each individual environment is hermetic and has no dependencies on others, right? So that was the biggest problem. We wanted to be able to build it from head, so no delays. Whatever current code is should be moved forward. We wanted 0 runtime dependencies. We also wanted to make sure to take care of one area of one source of problems we ran into quite a bit is when we moved from our staging areas into the production area. There was a short, small configuration file that described exactly how the different servers and the different CPUs were configured and what priorities they have, etc., for live production, right? And in way too many cases, we got into a problem where everything worked fine on staging, right? But essentially, no one believed that we are really done until we observed the same behavior really in live, because there were some not quite sure how we mapped this, right? So when we started out, we said, let's try and get rid of that problem, get rid of that insecurity. Let's let's see if we can build a system that is able to look exactly the same in our test environment, at least in the larger ones. And then when we swap over, we do not touch the configuration. 1 second. And of course, coming from where we're coming from, we wanted this to be test-oriented, right? So we wanted to be consistently designed for testability from the get-go. After almost 2 years where we created this system, what we have right now really is a system where all these various boxes that I had on the initial pictures, that's about 200 different services owned by different groups. Some of them in YouTube, some of them in Google, that we make use of. We have one environment where we actually can develop and test all of these components together. A nice side effect was that the engineers are now so involved in working on this system that there is really not that big a difference anymore between developing and testing, right? And it was almost a side effect. This was we said yes, we wanted the system to be targeted for testability, wanted to be easy to be tested on, but the way it looks right now is working in this environment equals to testing, which is great. Also, there is no separate integration phase anymore, right? As soon as you commit your code, it's deployed in this infrastructure, and you live in that big system, right? So we save the whole stack. And we actually hit the no surprise objective that we set ourselves to say, when we switch over, we don't have to care. We use exactly the configuration from the live system. If you remember the little explosion chart I had before, right? So we had a honestly unpredictable release calendar, right? Because of so many dependencies, we were basically continuously pushing. Right? Whenever something was ready, we started. Whenever the push was ready, we started over with the next one and worked our way through. And we went up to sometimes 3, 4, sometimes 5 weeks in really bad cases. And what we got today is a system where we have nightly builds that are ready for consumption if we choose to do so. And the main reason for this is really point 2 and 3. Right? There is almost no difference between development environment and test environment. And whenever you're done developing, you also know that it's actually working and we can push this out. So we are on a mostly daily. We don't hit every day, but most of the days we got a successful build. Not that is pushed necessarily into life every day, but it is something ready, which has the usual positive impact consequences, right? Small deltas in code changes from day to day. If something comes up, there is a small scope to look for bugs, etc. All the well-known things. So that was we were pretty happy about that, and still working now to get this completely 100% for all the 200 plus services. A few stragglers are out there, take a bit longer, but we plan to have this really ready and available. So that was pretty happy, and a pretty happy story, and it took us about 2 years to get through this, right? To build this whole infrastructure into which to dump these components. But well worth it, because now, you know, it's unbelievable the amount of time everyone saves by not going to wait for something or to look in a pile of code that is old for changes that may or may not impact the current thing. Sorry. On to the next topic. Mobile. So if you recall, we have this quote-unquote matrix that I have to care about on the client tier, right? While the mid-tier and the backends are pretty well moving on a daily click with new pushes for the live side. If you look at the set of apps that we now have, it's a slightly different story. One, we have to make sure that any of the mid-tier and backend changes keep alive all the variants we have out there, right? So on the browser side, that's easy because we push that as a whole stack, and they're in sync by definition. But for Android apps, iPhone apps, for the TV apps where we have no control of when they're actually shipped out, for Xbox or PS2, they have really long development cycles, or launch cycles, rather. We have to make sure that whatever we shipped half a year ago is still working with tomorrow's update of the live site. And that brings with it a whole new dimension of test matrix, if you want, right? We call it compatibility of what's out there to what will be available tomorrow in the servers. The way we tackled that was like this. So here's a stack of various development and or test environments, including the production system. Most of them we have in multiple variants. And the challenge was how to get the apps platforms connected to these integration environments or test environments on a not manual and not necessarily hardware device base, right? Ideally, you don't want just we have maybe 200 developers in that group running around with 10 devices each to figure out what works and what not. So what we did, the usual approach, two parts, right? We have a hardware lab that has a few hundred devices that are centrally managed, upgraded, kept up and running, that you can, as a developer, can log into and exercise your test or see your change. And they can connect to one or more of those development environments or test environments. Next to that, so these are as close as taking a tablet and start tapping, right? Next to that, we have the emulator set for, at least for those where we have emulators. So for Android, iOS, we have machines who do exactly the same, and that's mainly the basis for all of the automated tests. And then what we're still working on, made a bit of progress, but have quite a big spot on the map to still cover, is what I here call the dedicated hardware for, call them non-standard devices, right? So TVs, for example, is hard because I haven't found a good answer to automate on a TV for some Linux derivative that is reproducible. Sure, you could automate it, right? It's a huge effort, but then what do you do with the next TV? And the TVs seem to pop up every holiday season, like. So, open question. We have one where for the subset of all the devices where we have to run that have a video out card, where we intercept that and do comparison, golden snapshot comparison. That works pretty well. Brought us to the point where, for example, for HTML5 browsers on TVs, we can, for every of the daily builds, we run a smoke test that does this, right? And although Xbox is kind of the same story underneath, Xbox has a extremely long launch cycle, right? So we have said before, well, okay, we care about all of this when it comes more closer to the holidays, right? When there's an update. But in January, February, March, no one really cared about this yet. Where we are now is that with every cycle of the backend, we create the corresponding build, and we have, through these dedicated hardware setups, some way to smoke test those and say at least everything is still running with the version we shipped, which is nice. But as I said, this is a topic I'm really interested in talking to some of you, hopefully. All right, and then lastly, this is a summary of where we got here. All platforms, including those weird ones, we have found a way to validate at least the every daily push. So at least we know we're not breaking. Have automated smoke tests from those. And because we now have the automation platforms, the amount of testing that was manual was reduced dramatically, right? And I'm not an advocate for not having, not too many nods. I'm an advocate for having manual tests, right? Guess too many negations. I'm an advocate for having manual testing, but it should be exploratory testing, not scripted regression tests, right? So I don't want to spend every day when I create a new driver X numbers of hours to just make sure everything works, right? I want to spend that effort and energy on the new features that we develop to make sure they're okay. And with the platforms we have now, we were able, and we get a bit more of that later, we were able to cut the amount of manual tests needed on those devices to 50%, while compared to a year ago, while we were adding 3 different apps. So it was pretty dramatic reduction. The last topic I want to talk a bit about is what I here call the cultural change. So with all this automation, step back. 3-4 years ago, when we talked about testing in YouTube, it was a huge amount of manual work, right? Even when we had only the live site, the site, the browser-based clients, it was a huge amount of manual testing. We did unit tests, yes. We did some integration tests, but then most of the bulk was end-to-end, and most of the end-to-end was done manually. So one question is, as you introduce these platforms, you also want to introduce a culture where everyone knows these platforms and knows what to do of them, and it's as easy as possible for someone to pick those up and learn that, so that every developer actually has a easy way to get to the platforms and do the job, the testing job. So as an organization, we decided, okay, quality is a thing now. We need to somehow get to a better level of where we are. We want to reduce manual, but we also at the same time do not want to increase bugs, obviously, right? Rather reduce them. So we looked at where we are, and this is about 18 months ago or so, when we really set, 18 months ago, where we really set out to do this. And we took a snapshot of where are we today, right? Number of P0, P1 bugs out in life, how many do we find in the staging process, how many do we find here, the typical analysis, go there. We looked at it, came up with metrics of what are we actually want to look at on a consistent basis, and what SLAs are we setting ourselves? What's our goal, right? If we now have 20 P0s happening in a week, is that bad? Is that good? What do we want to do about it? What's the new goal? And we started pretty simple by saying wherever we are, we cut everything in half within 2 quarters. right? See where we come with this. Have to have a goal. So we set the SLAs. The next problem then was, how do we talk about these? How does everyone know where we are, and specifically where the team is that I'm part of, right? Am I doing okay? Am I improving? Am I slacking? What? So we wanted, we thought that in order to get these goals right, we need a tool that allows us to look at our metrics across the board and be able to drill up and drill down, go as big scope as you want, or as granular as you want, and say, okay, the organization itself does like this team is doing here, and find out who's doing well, where can we learn, how can we transfer best practices. We also thought about the different types of what quality could mean, right? There is obviously the product quality, right? Does the product do what it wants? Is it easy to navigate? Is it responsive? Is it intuitive? If you click here, this will happen. Especially if we went out to the platforms where the UI is so far away from what we were used to in the browser world, right? If you look at a TV or the kids app as an extreme, right? You have very different UI methodologies, and we wanted to have a statement on that level. Okay, are we okay? Where do we not as good as we think we should? The second topic was operations. So how are we with development excellence, if you want? Right? If the first is product excellence, the second one was developer excellence. How many bugs do we have? Where do we find them? How is our coverage? How many manual tests does it still need? That was my favorite, right? Do we still have manual stuff in regression happening, and where, and why is it not moving, right? And then the last test that was more specific for the test organization, to go after, are we doing the right things to help the larger organization to do their job? Right? And quite obviously, out of all this, we wanted to have automation wherever possible. It's pretty obvious that when we talk about this, everyone thinks of test automation. But there's lots and lots of other areas where automation helps, right? So if you think about the push process itself, how we release a product, we had lots of manual steps in between that slowed things down, were natural sync points, but also single points of failure if something didn't work out, right? So across the board, look for opportunities to automate, and one by one, take them down. My personal favorite goal, no manual regression. Not quite there yet, but we made some headways there. I already mentioned the goals. Was a bit ahead of myself here. So we picked where we were, we cut it in half, we said go, and then we tracked. And the tracking is, I think, more important than the actual goal, because you can also always reset the goal when you get closer and you think we should still improve, right? Then we mapped this back to, you probably heard about the OKRs in Google, so the commitment of every individual to the team. Okay, I'm going to do this, and we set kind of both downstream and from bottoms up objectives for the quarter, and these were kind of enforced objectives for the teams. You have to have this state in the metrics that we give you from the top, right? And those were the typical, okay, no P0s in production and kind of the obvious things. But we built the tool in a way that the teams themselves could come up and say, well, I have something that is really important to me for my interpretation of what quality means for my subset of the system that no one else really cares about, right? But for me, it's important, so we allowed this to be incorporated. And finally, we had also to do some work on who we had on board. That's specifically for me, right? I had a team mix 3 years ago that is dramatically different from what we have now, right? Now we have much more software engineer types who can actually build the tools and help automation and understand the systems, and less core test engineers concerned about larger system consistency test plans and things like that. We still have them, we still need them. My problem was I didn't have the other as well, right? So we built that up and now have a mix that is better equipped to tackle this. the most used, can't remember the American phrase, the tool that was most useful in this, that we used to get to change in the larger organization was this. You don't have time for manual, right? And because of that, you have to think about how to automate and what to automate, and let everyone else know what you need to do that so we can help you get there. So we said, okay, 3 years ago, on the main side even, we had every few weeks we had a push, and we said, okay, we go to daily builds, to daily launches, daily pushes every day. And if you think from 3 weeks down to 1 day, there's a lot of time you don't have anymore to do all kinds of things. Or you have to stop doing all kinds of things. This was the single most important decision we made from an organization to get to that. And this is kind of a current snapshot of where we are. You can see top left, the little downtrend. That's the amount of manual regression tests we still have in the system. We're about 34.5%, so about a third of all the tests that. So we classified our tests as okay, here are P0 tests that we call them, that have to run on each release before we say we can go, right? And 2/3 of those are now automated. And as I said, keep in mind which platforms we talk about. In some, I have no idea of how to ever get really down, right? And we added a couple of interfaces and apps. So I'm pretty proud of the takedown, but obviously not complete yet. Unit tests we kept pretty stable, which is also good, because of, again, of these new verticals that we launched, right? The standard, the default discussion at every point when the decision is made that an additional app will be launched is, oh, we have to go to market tomorrow, we don't have time for anything, right? And by experience, right, everyone knows that too, the first thing that gets cut back is work on automation, right? I'll do this when we launched, I don't know how the system looks like, how the interface looks like, I don't want to spend any cycles on this quite yet, I'll do this later, right? So looking at a coverage curve that stayed flat over those additional new verticals is, I think, a pretty good result out of this. And on the right side is our current snapshot over the last, how far back does this go? About a year, I think, yeah. About a year back on our release plans, right? So we set out that we want daily pushes, we want daily launches. And so this shows how often we hit. So daily in our world means 4, actually. We have a 4-day week. We didn't want to push on Fridays because we didn't want people to work on Saturday and Sunday to fix the bugs that we introduced Friday, potentially, right? So we said, okay, we want to go Monday through Thursday. And so we have a target of 4 per week. And here you see that we get 3.5 out of that most of the times. There are some weeks that have holidays in them where we didn't need 4 really. And as I said before, this, in my mind, was the best decision we ever made to push for this, right? Because that squeezed everyone's allowance for what can happen. We have right now a honest test window on the release level of 3-4 hours, where testers actually go and manually do something. And even that, on the apps, we have reduced to exploratory. So they're not going through scripted tests, but they spend this time to just say, okay, you know the app, you know what should work, let me know whether you think we are good to go or whether something is off. What remains was the question of how to talk about this, right? How do you let the organization know how we're doing, and how do you find out where we're not doing so well and we should refocus and change things that are not working? So it's an eye chart. You're not supposed to read this. Just give you an overview. This is how the tracking site looks like, right? So this is an organizational chart if you want. You have YouTube as the top organization, and then you go through the different, you call them functional areas and investment areas and teams. So we picked 3 levels down. split the world up into a tree of depth 3, projected it, and said, okay, so here's who we look at. And then we track for everyone a mix of a fixed set of matrices that are pre-described and you can't opt out of, and a arbitrary long list of matrices that team-specific we use to say, okay, for the video delivery team, they have a few matrices that the Android app doesn't really care about, right? Okay, you put it in, you leave it out, fine, but once you put it in, you'll be tracked, right? And then you can drill down, and you get a slightly different view of the various aspects and dimensions we have. I mentioned before, we look at product, we look at release, we look at test. And further down, this is the lowest level, my group actually could go and say, okay, how are we doing? Oh, we had some production bugs in P1. This is probably this tool we're talking about that had a bug. And you see kind of very easily where are hotspots, where did we not meet the SLAs. We still think in 6 weeks sprints. So this little bar chart you see up top gives you the history of the last 8 or 9 6-week sprints next to each other. So you also get a trend, whether you're actually improving or you're degrading. You keep your level. You see pretty quickly where you should be concerned about and where you're doing fine. And then the next step, obviously, after that is to think about ongoing improvement of this. But what we got out of this is now a vocabulary to talk about quality in this organization that everyone understands. Everyone knows where to go and look. Right? All these matrices we defined, even if it's in a team that is next to you, you learn a bit about what they care about. It is transparent. Everyone can look at this. There's a bit of public shaming going on, obviously. Right? You don't want to be the one red spot in a long list of green, all positive things. And mapping this down to the teams allowed also to have it very easy to know who to talk to about a problem. Right? It's this team, and I don't care which component in the code and blah, blah, blah. You do this yourself, right? This team shows up as red or as declining. We need to talk, do something about it. It's really cool. And what's left here? So we want to think about how do we, if we are at green, and some of those have some history where there's 3, 4, 5 sprints on green, what does that mean? Right? Does that mean we're done? Or does that mean we should look at the goal we set and whether we can improve that? Right? There is an ongoing discussion, especially with the aforementioned fast-to-market needs of teams, right? Which is a reality. When I look at our gaming app, we wanted the gaming app out there as fast as possible. But the question is, what is as possible? What does that really mean, right? What are you willing to jeopardize in order to get there? And obviously, in the way of getting out there as fast as possible is all the process, I would call this process work, around it to actually keep everyone from running too fast and introducing too many problems, right? So that's an ongoing discussion that, on the plus side, actually is on the surface. Right? It's not some hidden, just one team has this problem. It's on the surface because we probably see a lot of red area in this, of red color in these areas, and we are forced to think about what we do. Another slightly hot topic in the existing culture is how far you go with asking people to do things a certain way. Right? We typically try to stay way back from that statement. Right? You can choose your tools, you can choose your development process, you can sprint or scrum or do whatever you want, as long as you deliver, right? But we are now at a point where we start seeing teams who do really well and can see the positive trends and impact on that, and think about whether we want to turn this around and not say, okay, you can use this or this or this tool, but to prescribe one tool set across a larger part of the organization. And if you're not in that, you need to have really good reasons. Right? but we're not quite there yet. It's on the table. My biggest problem, we still have platforms that are hard to automate that we haven't cracked, that I'm just without a good solution. We are almost on push every day, every work day, or every push day. So pretty consistent for probably 80% of the code base or the component set. And we're now starting to think if and how we push this forward, right? So daily, should we have 2 a day? Should we have 4 a day? What's the right number? Should we push every time code is ready? That we call push on green, right? Code, you submit your code, it goes through all kinds of tests, and at the end of that process, you're live, right? How far on that dimension do we want to push? Not quite obvious. Team identity cross. Let's talk about my other big problem of getting the right people for this type of work, right? Which I found rather harder than I expected. Hiring is a real struggle, both in terms of numbers and in terms of the right skill level, or the level and skill set. People who are really passionate about this topic of not working on the front, look, mom, I built a new app, but more in the back office. This room is probably more, it's much more easier to convince people here to do this type of work, but if you go to the general SWE software developer population, they're hard to find, very valuable and hard to find. Now I remember what this other bullet was. Another organizational problem on the team is, if you recall, I try to give a flavor of how diverse and how broad the technologies are, the set of technology is that is used to build this YouTube offering, right? And almost in every area of technology, there is a specialty for how do you actually validate this and make sure you have improved, right? So you think about machine learning and model-based testing as one example. You go down and you have hardcore video image processing things, right? You go up to the apps and you have UI, human-computer interaction topics, right? So it's a broad set, it's a broad spectrum, and we have not that many people. So most of them are specialized in some of those areas, right? And that's what I meant here with the team identity. How do you make these 100 people that do this feel as one team that solves this problem for YouTube versus, oh, I'm in the search group, oh, and I'm in the personalization group, and I do this other thing, right? That is, ongoing struggle. And then the hiring. So, thanks for your time. I hope it was a bit interesting. I try to not get into too much of this is the tool we use and this is the language we do it in, right? But more on a higher level to see whether we can have some discussion. I'm here for the next 2 days. Very eager to talk to you guys about how can we do this better, what are your experiences. So take it as one of those experience drops in the back and see what it can do for you. With that, thank you. Not sure how we're doing in time. Do we have time for questions?
We are good for questions.
Excellent. Will this show me the
In theory.
the online? Okay.
Because it wasn't showing up on my phone.
There we go.
Can you click so it's showing the top tab, please?
You moderate, right?
Yeah.
Okay. There's a -1. What does that mean? Don't ask that question.
Oh yeah, apparently I'm not allowed to ask you that. I feel like I want to,
I
though.
didn't know you had
It's that red button. Could you describe the transition to a test environment that matches production?
I'll try. So the problem was that in our production system, the configuration information is stored in config files, right? The old Linux tradition. So we have information about which data centers to deploy to, how many CPUs, what priority level of these CPUs, who talks to whom, what is the backup philosophy, etc. So there's a lengthy description of all these configuration flags and what values, etc. Typically, in your development environment, you don't have or need that detail, right? So if you ignore that and just think about the development environment, you probably also come up with some configuration, but it doesn't have all the intricacies, and especially not all the tuning part that we have in the live world, right? So the problem was that you basically have two different system configuration descriptions, right? And while you know in your development environment everything works fine, there was a pretty good level of uncertainty about what happens if I deploy into this one with this set of configurations, to say, you know, we don't have to redo all our testing again. That's where we started out, right? We were done here, and then we deployed, and as we slowly rolled out, we rerun lots of our tests just to make sure, quote unquote. It's a quote, just to make sure, right? And what we now have done is to start out with the configuration files of the live system. Use that as input to the development system, right? Ignore what can be ignored, really that we don't care about, but make sure all the rest is exactly set like it is in live, right? Even if it's overkill and even if it's too much and we don't need this, who cares, right? It makes the step from one to the other so much less error prone. So that was the problem I tried to describe. Sorry if I wasn't too clear on that.
If you accomplish the goal of having no manual regression, how will you validate the look and feel?
So I think I mentioned that as well. I don't want the regression, the manual regression, to be scripted, first of all, right? So we do right now allow a time window of these 3 hours that we have when the new level is ready and it starts really to get rolled out. We use that for free-form testing, right? For exploratory testing. What I don't want is to say, oh, I have these scripts, and these hundreds of scripts have to go through, and the only way to scale this is to get more bodies in front of keyboards, right? That's what I don't want. I want these scripts to be in the other world where they're run automatically, so that exactly this can happen in the time we have. You shouldn't worry about, okay, does this result in that, right? You should worry about, does it look right? Did we break some of the usual things in internationalization, and right? Does it look right? Is the integration of the new feature into yesterday's system actually looking out there as it should? Things like that. So it's exactly that, I think, that I want. No manual scripted regression, but use the time for exploratory.
And I will tell people in the local audience, I am primarily taking questions off of the website. So if you want to ask one, feel free to add yours there too. This one might be hard to answer.
Yeah. Yeah.
Because
I think we should have.
know the answer.
I think we should have a conference on tools.
Yeah, what tools
How
do
about
we
that?
use, Jürgen? Can I share some of yours? Well, we can share, but can we share it with these guys, what tools we use?
So we could share. Usually what is behind the question is, can I use that too, right? And this is where it gets a bit tricky, because a lot of our tools are specially made for the whole proprietary stack that we built. So it starts, everyone knows that too, it starts with a low-level, slightly tuned Linux system that has its own compiler and its own, and then you walk up the tree, and if once you get to the test environments, a lot of them are very, very finely integrated with 25 other systems. Although, on the other hand, we have a few that we open sourced. WebDriver has been a very prominent one. There are some, but I honestly don't know. I mean, if you have maybe a list of 25 to 30 different tools that make up our environment, if it's 25, 23 of those are not really reusable outside.
And one of them is Google Drive for sharing test documents.
That is true, yeah. But not in spreadsheets anymore, right?
No
No,
test case management in
You
spreadsheets.
don't do that anymore. But maybe also want to mention that one of our big work, our Google big work items since a few quarters, is to bring a lot of these development tools and testing tools out into the cloud for developers to use and share, right? So while right now the only path for us really is to go through the work to open source something that we use, if you think it's really can be abstracted away and still is useful, right, by itself, to say, forget this, a whole different approach, here's a stack of tools to use if you develop on this platform. Then you get all these tools for free, build tools, integration tools, rollout to deploy, blah, 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 blah. Including the platforms to run the tests on, right? So including emulators for Android platforms, or even labs that run real physical machines that you can, as a developer, reach. That's still a bit out there, I hear. Maybe another week or two, right? But it's coming.
Become friends with the Google Cloud tester and find out what you can about what is currently available in that space. Thank you, Jürgen.
All right. I'm around. And really would appreciate you reaching out. The clicker, of course. Thank you.
He keeps trying to steal my clicker. So a little housekeeping before we go on to the next one. It will be only a second, guys. We have some empty seats. If you guys could smush in so that the seats on the aisle are the empty ones, we're going to be sending some poor folks from the overflow rooms in the next break, or actually, hopefully at the very beginning of this talk. So please help us out with that. It is okay if you absolutely have to sit in one of the hearing impaired seats because there are no other seats left. Hopefully we've already accommodated those who need them. And if not, let the committee help those people find the proper seating so that they can see. Next up, we have two engineers from Uber who have come to talk to us about Octopus taking on the Uber challenge. I'd like to welcome Apple Chow and Bian Zhang from Uber to the stage.
Hi, everyone. My name is Apple, and I manage the mobile test infrastructure team at Uber. I'm very excited to be here today. So first, let me give you some information about myself. I am an ex-Googler. I was at Google for 9 years, and I led the testing team on a wide array of projects, including YouTube, Hangouts, and Google Maps. At first, I thought I've seen it all in the world of automated testing. When I joined Uber in March, however, I found that the level of challenges we face at Uber is at a uniquely different level. I'm very excited to share with you some of the technologies we built from scratch to solve those challenges at Uber. And we are also planning to open source some of the solutions very soon. So I hope that you'll find something useful in our talk today, which you can apply to your projects. So what is it that makes testing Uber unique? Before I reveal the answer to my question, first, let's take a quick survey. How many of you have used Uber? Wow, that's a lot of you. That's great. And my next question. How many of you know that there's a separate driver app? I see, not that many of you. OK, now to my third question. How many of you have ever tried out to be an Uber driver? Well, there's lots of perks about being an Uber driver, but that's not the point of today's talk. So after my previous hint, now can you guess the answer to my question? What makes testing Uber's mobile apps significantly different from, let's say, testing Google Maps? Anyone want to tell me the answer? Any guess? 2 apps? Good, that's great, yes. So what's our Uber challenge? The driver app and the rider app are tied together. So this is one of the first challenges we faced when we were investigating UI testing tools for automating the sanity test scenarios for the mobile org at Uber. We found that many of the scenarios require the rider app and the driver app interacting closely with one another in order to complete the scenario. So how do we solve this? And now let's first take a moment and think about our current and previous projects. Have you ever encountered a case where multiple users have to collaborate together in order to finish a scenario? And have you ever faced a scenario where you have users, your app has to talk with another app in order to finish a scenario? I can immediately think of a few cases where this applies. For example, at Hangouts, we have one-to-one or group conversations or video calls where multiple users have to collaborate together to finish those scenarios. Also, my friends, at games, there are so many games that require multiple users participating together to finish a game. So basically anything that involves multiple users talking with one another in order to finish a scenario will face a similar challenge. So what's unique to Uber is that our core flow is consisted of many distinct steps that are happening not just across different devices, but across apps, the driver app and the rider app. So that makes it even more challenging. I think the more common case is that you have multiple devices interacting with one another, but still with the same app. So how do we solve it? Our solution is called Octopus. So even though our challenge is unique, our solution is a generic test runner that can be applied to run any scenarios that involving cross-device or cross-app communication. So, ready to see Octopus in action? First, let's watch a quick demo showing the interactions between the driver and the rider for our core trip flow scenario, where the Uber driver is giving a rider a ride. Then, we'll look beneath the surface and see what Octopus is doing. So in this demo, you'll see Octopus launching two Android emulators side by side, one running the driver app and one running the rider app. So let's play the video. So here you can see the rider and driver both sign in. The left side is the rider, the right side is the driver. So first, the rider sets the pickup location, and then the driver goes online and is ready to get requests. Now the rider on the left clicks on Request UberX to request for UberX. Driver gets the dispatch, accepts it, and is en route to pick up rider. Driver then picks up rider, begins the trip. The rider on the left sees that he's now on trip. And driver arrives at destination, drops off rider, rates the rider, and then rider will rate the driver. So this is the sequence of our most basic trip flow scenario where the driver gives a ride to the rider. Now think of a more complicated scenario like the Uber pool. I'm not sure how many of you have used Uber pool. In a Uber pool scenario, you have one driver and usually at least like 2 to 3 different parties of riders. So over there, you have 3 to 4 devices collaborating together in a scenario. So the synchronization gets even more complicated. So now, let's look at the scenario step by step. Remember in the previous demo, I showed that Octopus launched both the driver app and the rider app at the same time. And each of the driver tests and rider tests goes in and execute their own sequence of steps. Now let's imagine what could go wrong there. Remember that those two tests are running in two separate processes. I mean, even though it looks like it's all together in one scenario. So underneath the cover, it's running in two different processes. What if the rider logs in before the driver and requests for the ride, before the driver is ready to accept the ride? Then the request could time out, and then you wouldn't be testing the scenario that you want to test, right? So how does the rider know that driver is online and now I can send the request? So this is where Octopus comes in. So Octopus, we introduced this concept of signaling. So using signaling, Octopus can, the driver app can tell the rider that, hey, I'm online now. Now you can request. Then the rider test can go ahead and request. So using signaling, Octopus allows you to set up different checkpoints along your test scenario to make sure the steps are executed in the right order so that you can still communicate with one another. So with Octopus help, so here's the correct sequence. So after they log in, first, the driver goes online by clicking on Go Online. And then the request goes to the backend, and the backend acknowledges it. Now, Octopus sends a signal from the driver test to the rider test and say, hey, I'm online now. Now you can request. The rider test now clicks on Request UberX, and the request goes to the backend, and then the dispatch gets sent to the driver. So in a similar fashion, you can see that along the way, you can put in different checkpoints. For example, after that, maybe the driver can tell the rider, hey, I accepted the ride. Then the rider test can check the status bar on the top and say, okay, I can see the driver is en route to pick me up, things like that. So let's talk more about Octopus. So what were all the reasons behind why we built Octopus? First, we wanted a unified test runner for both our Android and iOS apps. Secondly, we wanted extensibility so that our runner can be integrated with different UI testing frameworks. Thirdly, we wanted to support parallelized runs so that we can speed up our tests. And lastly, as I shown in the previous demo, we want to support signaling so our tests can communicate with one another even though they're running across device and across apps. And most of our talk is going to focus on the signaling functionality since that's what enables us to do the cross-app and cross-device communication. And what does Octopus do? Well, Octopus streamlines the following functionalities in the command line. So whether it's run by an end user on a laptop or it's running by our Jenkins CI, it's running the exact same command. So this makes integration with Jenkins super easy. So what does it do? First, it prepares the test targets. So test targets, I mean, either it can be a device or it can be an Android emulator or iOS simulator. So it installs the apps on them, puts all the test configuration test data on the device, and launches the app, for example. And then it runs the test and then handles the underlying communication across the different tests using signaling. And then at the end of the test, it creates the test reports and also pulls all the necessary test artifacts like bug reports, screenshots from device or emulators, and performs any necessary cleanups. Now, let's see another demo of Octopus in action. In this demo, you'll see Octopus launching multiple iOS simulators at once and runs a test on them, wait for all of them to finish before it finally exits. Let's play. So here, you can see Octopus launches 5 iOS simulators. Each represents a different iOS version. So it runs the login and logout for all of the simulators. And one by one, they log out and they exit. And Octopus will wait for all of them to finish before it finally exits. So Using parallelized test runs, we can use it to shard our tests across multiple test targets to speed up our tests. Another usage is that it's similar to the web testing world. You can run the same tests across different iOS versions to make sure the test runs for all of them. So now I'm going to hand it over to Bien, who's going to deep dive into the design of Octopus.
Thank you, Apple. My name is Bien. I'm from the mobile testing infra team at Uber. So before joining Uber, I was working for Facebook on the performance testing framework for mobile applications. Today, let's talk about some technical details. But before that, let me share with you some of the design philosophies. So first of all, we want to make sure Octopus is easy to use. So all the demo you see today in the slides is triggered by a single Octopus command line, which is unified and simplified across different platforms. And we want to make sure Octopus works the same way with different platforms like Android, iOS, simulator, emulator, and real devices. And we chose to integrate with the existing testing frameworks, such as UI Automator, Espresso, or iOS UI Automation, so that the developers can use the platform-specific functionalities directly without introducing another layer. So let's talk about signaling. Before diving into the technical details, let me share with you some of the terminologies. So the test host is where Octopus runs. It could be a Mac Mini or a laptop, which you work on every day. And the actual test code is running on the test targets, which could be simulators, emulators, and real devices. And between test targets, we have communication channels. And in the communication channels, we pass around signals. We want to make sure the Octopus is simple to understand and easy to implement. So we just use the very simple strings for signals. And it's the test targets and test codes' responsibility to interpret the meaning of the signals. For example, driver online, as Apple mentioned earlier. So how does it work? Using the same example in the end-to-end trip app just mentioned, we have a driver test target and a rider test target. So first, the driver sends a driver online to the rider test target, and the rider test target requests for a trip and sends back another signal telling driver that I've already requested a trip, and you can proceed and do the further verification UI or test steps. So on top of the high-level workflow, we introduced two very simple APIs. The read signal, which will block until signal is retrieved or is timed out. It's read the signal from a channel, and it returns the string or timeout. And correspondingly, we have write signal, which writes another string to a channel, which is a long blocking call. The API works as below. Using the same example, we have a driver and a rider. So first, the rider calls read signal on a channel called rider inbox. So by looking at the name, you know the rider inbox is a channel which contains all the incoming messages for the rider. And then the driver will call the write signal on the same channel, rider inbox, with the signal called driver online. And this function call will trigger the return of the read signal on the rider side. After that, the driver waits for another signal by calling a read signal on another channel, which is driver inbox, which is all the incoming messages for the driver. And this read signal function call will be triggered by another function called write signal from the rider side. So this is how the API works at a very high level. So how do we implement that? At a very high level, we have the two-way communication channel between test targets. But internally, we have two one-way communication channels, like the rider inbox and driver inbox. So it's a typical P2P communication between two test targets or multiple test targets. So it's really easy to think of some P2P technologies like Bluetooth, direct internet connection, NFC, or AirDrop. So we have plenty of choices. But we do have a problem, which is the consistency. Because one technology might work perfectly on one platform, but not on another. So if we choose different implementations or different technologies on different platforms, we will end up with multiple implementations for different platforms, which will increase the complexity of our system. So we switch to a more consistent way, which is the relay via test host. Because in the test scenario, the communication channel between test host and test target is always consistent and reliable. So in the beginning, we chose a client-server architecture, which is very easy to think about. So the test target and test host communicates with some network protocol. This is easy, and this is typical. But there's a problem in this architecture too, which is the reachability. Because your test host, your Mac mini or laptop, is usually running in a protected network, like your data center or your CorpNet. But your test target might be running in the cellular network or public Wi-Fi, or even no network if you want to test it offline mode. So it's not guaranteed that the test host is always reachable by the test target. So that means we need to find something more reliable and always available. Because we're running a test scenario, so we chose a more reliable connection, which is a USB. So imagine you are doing a device testing. You always connect your device using USB cable to your test host. And it works the same way with the simulator and emulator because the testing framework provides the consistent communication channel between test host and test target. So by using this, we implemented a virtual two-way communication between test targets. So now we have the communication protocol, or we have the communication channel. What do we pass around in the communication channels? We chose the most fundamental and most reliable storage unit in the operating system, which is a file. Here's how it works. So first, the driver generates the file containing a string called driver online on the test target. And then this file is passed from the test target to the test host. And the test host relays the simulator, the signal string to the test target. So logically, we have the same implementation of write signal. So now the question becomes, how do we pass around files? So specifically, we have two questions to answer. The first one is, how do we send a file or a string from test target to test host, which is essentially the implementation of the write signal. And correspondingly, we have another question, how do we watch or monitor a file on the test host from the test target? Because your test code is running actually on test target, which is essentially the implementation of the read signal. And this is where Octopus diverges on different platforms. So let's talk about them one by one. On iOS, the iOS re-automation framework provides a very convenient API called UIA host perform task with path argument timeout, which is essentially the equivalent of exec. So by using exec, you can essentially run any shell commands on the test host, which is really convenient. So with that, the write signal and read signal become very simple to implement. So for the write signal, we just write something to some file on the test host. And for read signal, we just use a cat to check the content of the file. So the actual implementation of read signal on iOS is a little bit more complicated. We have a shell loop, which constantly checking the file content for the signal, and then trigger the return of read signal once the file content has changed. On the other side, on Android, so unfortunately there's no direct exec. Everything should be initiated from test host. So we have to use ADB shell as a relayer. So here's how it works. For the write signal, the test host starts a daemon process which monitors a signal file on the test target, on one of the test target, using ADB shell. And then the driver generates the file or changes the file content on the test target, which will be detected by the test host, by the daemon running on test host. And then the test host grabs the file from the driver test target and relays it to the other test target for the rider. So logically, we implemented write signal from the driver to rider. Because we are pushing a file directly to the rider test target, so the read signal becomes really simple. We just use the file observer on Android to monitor the content of the file. Once it's changed, we trigger the return of the read signal. So as you can see, the design of the signaling Octopus is really flexible and scalable, so that it's very easy to implement one-to-one signaling, one-to-many signaling, as well as many-to-many signaling. And the majority of the implementation of signaling is platform agnostic. The only thing that diverges is the actual file observation on different platforms. So that it's easy to implement the cross-platform signaling. Imagine you have an iOS rider talking to an Android driver. So given that, I'd like to show you another demo which shows the most complicated test scenario in a Uber application, which is Uber Pool. So as Apple mentioned, if you have multiple riders coming to the same location, they can share the same car with the same driver, which requires one driver and multiple riders. So as you can see, we have 3 simulators, a driver and 2 riders. All of them sign in. The driver goes online. And after that, it sends the driver online signal to the first rider. Then the first rider pick up a location and select the destination and request for the share ride, which is Uber Pool, which will be captured by the driver. And the driver will pick up the first rider and then send another signal to the second rider saying, I've already picked up the first rider. The second rider can start request the Uber trip now. So the second rider got the signal, pick up the locations, and request for a share ride. And as you can see, on the driver side, the second pickup has different UI. So we will have different verifications of the test steps. And after the 2 riders are picked up, the driver will start the trip and then drop off the first rider, and then the second rider. And after that, the driver will rate the riders and end the whole test scenario. So as I mentioned, the whole scenario is triggered by only one Octopus command line. It handles all the device bootstrapping, initialization, and the coordination, synchronization between test targets. And the synchronization is handled by Octopus signaling. So that's all I have. Questions?
So the first 2 questions are pretty much duplicates, which is, why is there a need to test both the apps at the same time? Why not simulate requests and responses or have fake backends?
Okay, I can answer that.
Yeah.
So we do have different test modes. So this one is the full end-to-end test mode. The reason why we need this is sometimes we need to test the different configurations on the server side. For example, we have a test city with certain functionalities enabled. We have other test city with different functionalities. Though we have some dynamics on the server side, we want to make sure we have a test scenario to cover different scenarios, both on the client side and the server side. So that's why we need end-to-end, which simulates both the driver and the rider side.
I mean, this is not like a replacement for like unit tests or your medium level component tests where you can mock out server responses. This is meant for a small fraction of your, like your core happy path tests that give you the final confidence that your system, the high level components in your system is connected correctly. So it's only a small fraction of it that gives you the final confidence. So we're using all different modes in our tests.
It seems like it would be hard to identify root causes of test failure when there are two-step units under test and there are associated tests in different process spaces. Has this proven to be a challenge in practice?
Actually, for using this is actually makes our tests easier to debug because each test is only waiting for one thing at a time. So when something fails, there's no doubt about like, oh, for example, did the driver go online before I request? Like if something fails, you know that, okay, driver already sent a signal that's online. That means like something on the writer side failed. So versus if you don't have this, you'll be like pulling for different conditions, and sometimes the conditions are not even visible on the UI, and it's really hard. So I think having this definitely makes the test actually easier to write and easier to debug.
Do you experience flakiness when sending signals between emulators?
So because the test codes are running on different simulators, so the communication between them is challenging. So that's why we chose the as reliable approach as possible, like the file-based signaling, the USB connection to reduce the flakiness. So far, we didn't see many flakiness. It's pretty stable because we use the most reliable technology.
So far, this is actually more reliable than like Appium that we look into, for example, with the client-server architecture. So far, the flakiness we found is not from the signaling. It's more from like the real-time server responses. Occasionally, it times out or something happens there. So, but it's not about signaling.
Okay, could you clarify what the system under test actually is? It sounds like my question left. I'm sorry. Do you have it, Diego, that I can read? Is it back there? Oh, yeah, there it is. Thanks, guys, for upvoting. It sounds that you compromise performing end-to-end testing with your test infrastructure in between the apps, which is not the case in production. Could you elaborate on that?
What's that?
So what are you actually trying to test with this type of test is basically the question, and what were the compromises made, or what other things did you have to put in place to mitigate any compromises?
I think on top of having unit tests and then the test that tests, like if you mock out the driver and look at the writer specifically, this allows you to test like the core flow of the more complicated interactions between the two to make sure when you go through like the core chip flow, which is like one of our core cases, right? To make sure like each app can go through the expected sequence of state changes and then is able to complete the trip and complete the happy path, and then at the end they can reach each other.
So Octopus is not making any modifications on the application itself. It's not modifying the backend as well. So we're testing whatever we have, either it's production or it's the staging environment or it's the beta application.
Well, thank you, Apple and beyond.
Thank you.
Thanks.
We are at time for a break. Restrooms are located in the common area. There's coffee, tea, water, etc. out there. Be back by noon. We've got a robot to watch.
this, I assume. Device is still off, just so. Yeah, I want to make sure.
Oh, Jeremy. I was looking for you. That guy back there? You do your work. Yeah, you do your work. Yes. I'm gonna need that. Oh, good, good. Good, good. Don't wait for me.
Take the badge too. hyvä distraction, että kaikki katsoo sitä.
Tää katsoo tonne pöydän yli. Ei kai nää ole.
Ei se ole. Aika kaukana on.
Nää mikit on ei.
Aika selvästi kuulee. Ja nyt on varmaan tietysti aika paljon äänen absorboijaa tuossa.
have a chat right here. Hey, little robot. Welcome back, everyone. As you can see, we have a new presenter on stage with us. By the way, if you hear the cowbell live, you need a better watch or phone that keeps time. So please don't hear the cowbell live. For everyone here, remember, we are posting the slides online afterwards, so don't feel compelled to write everything down that you're seeing on the slides or the information or whatnot. That will be available later. But without further ado, I bet you're wondering what this robot does. I am. So Hans and Natalia from OptoFidelity are going to talk about robot-assisted test automation.
All right. Hello, everybody. My name is Hans Kuosmanen. I'm a VP of Test Solutions at OptoFidelity. I'm here with Natalia Leinonen, who's our senior software engineers, and we're really excited to have this opportunity to tell you guys about robot-assisted test automation. So the things that we're going to go through today, first of all, I'm just going to tell a little bit about who we are and where we're coming from. And we're going to tell you things about measuring user experience of mobile devices. Also the hardware testing landscape, where the requirements are coming from and so forth. And also when you should use robotics to test applications and devices. We have a short case story about Google Chrome TouchBot that we've delivered during the summer. And then we will have the demo, which everybody probably waiting for. If we have time, we're going to have some Q&A later on too. So first, I'd like to tell a little bit about OptoFidelity, partly because the marketing people just told me to, but also because I like to tell you what's the background of the company. So we're a Finnish company established in 2005, and we've been working with test automation for R&D for mobile devices. So we're kind of like hardware-centric people. We have a heavy competence in the optical test and measurement, so imaging, machine vision. That's pretty much the projects that we were working on in the beginning. And then at about 2008, we started getting more and more involved in robotics. The reason for that was the emerging of touch panels and touch sensing on those devices, on mobile multimedia devices. So far, we've been delivering solutions to pretty much all the major ecosystems, and also to most of the chip vendors that provide technology to smartphones and tablets. In the space of mobile device testing, we are pretty much the leaders in robot-assisted test and measurement automation, which means that utilizing robotics in activating the products, simulating humans. We're kind of building a human simulator for testing devices. The human-like UI performance testing is something that we are using high-speed cameras and external sensors to measure the actual user experience of the end user of the product. It can be either application or just the device itself. On touch performance testing, we have delivered systems for characterizing, calibrating, testing touch sensors, very accurate robotics involved there. The first project actually that we started off with was about video quality testing, so perceived video quality of mobile device. We have technology we can measure and analyze video directly from the screen of the device, because many times you don't have access to the actual video playback, or you don't have reliable access to it. And one thing that's pretty close to the video playback is the UI animation and how smoothly the UI is actually working. It also gives the end user the perception if the UI is good or if it's bad, if you have like frame skipping or things like that when you're actually operating, opening apps or switching to between apps and so forth. There's actually also some images of the type of robotics that we have delivered. So this is just one example. So we provide a lot of different platforms, a lot of different form factors for different applications. Then to the subject of measuring the user experience. I mean, user experience is kind of a large concept. So there's things like look and feel, and what kind of colors you need to have on the UI. That's not within our scope. So in our scope, we are looking for things that we can actually measure and give measurement results, raw data. There's a couple of things on the slide there that are contributing to a good user experience, and these things need to be in order for the end user to perceive the quality as being good. I just want to highlight a couple of things where robotics is going to add some benefit and some value to the testing. One obvious thing is the touch sensor. So there's really no other way to characterize, to validate the performance of touch other than having robotics in there and artificial fingers, styluses, and what have you. And the touch is really something that's emerging also to wearables and to cars. It's pretty commonplace already in the smartphones and tablets, obviously, but there's a lot of different applications coming up. Even just household appliances are having touch on it. So touch is really big thing. I'm sure there's a toaster with touch interface on it. So we are providing solutions for the touch accuracy, touch responsiveness. There's also proximity, like hover of the touch. That's another user input to the device. Also force sensing, and now like Surface Pro and the iPad Pro now the stylus seems to be coming back as an input solution or an option, and it seems that there's much more technology behind it. So it's not just the replacement of the finger. There's like angle and force sensing on those devices also. So we can provide the equipment, the methods to test and characterize all of this. Imaging is another very important area. I mean, we heard on the keynote that there's 300 hours of video being uploaded to YouTube alone per hour. And everybody's 20% of internet users they have an Instagram account. Everybody's posting, even me, posting their lunch pictures and breakfast to Facebook. So end users are expecting the image quality to be perfect and the video, recorded video to be really, really good. So what that means is that the device manufacturers have to find ways of how to get a better image quality, how to get a better video quality. And it's not just adding more megapixels. It's like integrating the sensor, like acceleration, gyros, all this into the imaging chain. And this makes it very complicated to use software-based instrumentation in the product because there's so much interaction between these different hardware components inside the device. Then there's much more sensors being integrated into the products, like near-field wireless sensing and gyros, acceleration, you name it. There's more and more stuff coming up. So the more complex the device gets, the more interactions you get, the more difficult it is to use software-based agents to measure and to test and validate. So we are focusing on doing all the testing non-intrusively, so we don't have anything running on the product. We're using external sensors, cameras. We're using robotics to activate the products. And this gives us much more robust way that works across different types of equipment and devices. So the UX being a very broad term, where are the requirements coming from? So, well, the requirements are coming from the end user. That's one of the reasons why we're kind of doing the human-like testing. We're trying to test the way that the end user is perceiving the operation and the feedback from the product. The app solutions, app and solution developers are kind of the in-between messengers to the operating systems, ecosystems of what kind of features the end users are looking at, and also finding new ways, new attractive features for the end user to want. So that information kind of gets into the ecosystem level, and then there's a whole complete value chain behind it for building those devices and validating the components that go into them. There's certification in some cases, like Google has the CTL, I think, and Windows has the HCK. So there are some requirements that come from the user, the end user level into the actual hardware and the components. But oftentimes it's just the equipment manufacturer that pretty much make up the requirements, make up the limits. And then all these limits go in, and the methods and the limits go into the value chain to R&D teams, to production of the equipment, to after sales, like refurbished business. All these guys are using the same requirements then. And our solutions, as they are like end-to-end, non-intrusive ways, you can use them for all of these different players on the ecosystem. The other way to look at that is like the product life cycle. So first you try to validate the components and the actual bits and pieces and the chipsets and what have you. So the chipset and platform suppliers are doing most of the testing. The device manufacturers get into, once they start to integrate these into products, then there's going to be functionality, stability, and interaction of those hardware components. The device OEMs start to do most of the testing. And then once the products are launched and once they are like finalized and new versions come out, there's a whole area of system level testing that I'm pretty sure most of you guys are involved in, that involve the software, the applications, the server backends, and what have you. So you got operators and service providers, application developers are more doing the actual testing. But this might, it's kind of a living thing that some of that testing is kind of going back to the device level also. So there's, not all the platforms are very stable in a way that you have to take into account a little bit of the hardware, and that's why there's a lot of talks also in this conference about testing in the hardware. It's very important. You can't just go and test everything on an emulator. So instead of just using a device cloud, when would you be testing with a robot? Well, you could test everything with a robot, but a lot of times it doesn't make sense to have all your test cases run on that. But there are specific areas where the robotics is going to add a lot of benefit and a lot of test coverage to your test portfolio. Most important is the complex interaction. So more and more hardware components, more and more applications are running at the same time when your app is running. And oftentimes it's kind of hard to make sure that your test conduit or your instrumentation is not actually one part of that complex interaction and affecting your test results. Also, when you're using production software, you might not have all the instrumentation available. You might not have all the debug features and the hooks. Or if you're testing how your devices are booting, like this is more like operating system stuff. So if your device doesn't boot, how are you going to get your instrumentation software up and running? So a lot of times you need some sort of robotics, like just pressing the power button or disconnecting a power cable or something like that. In medical industry, there's a lot of regulations that you cannot have any instrumentation in your system. You can't even have extra hardware components in it to pull out a display to a frame grabber or something. So you don't really have the means to get the data that you could use on your test cases. Whenever you need controllable, repeatable UI actuation, that's also a robot will do it. You can do it per millimeter, even 100 micron, 10 micron even. So if you need to move the product around, for example, to activate the sensor layer of it, then robotics is the way to go. Also, if you need real-life sensor data, like image stabilization of a camera, for example, when you're optimizing your algorithms, it gives a lot of benefit to actually move the camera around, move the targets around in a predetermined fashion so that you can iterate your software using the same test conditions every time. Benchmarking against your neighboring operating system is also one thing that if you're doing it with software instrumentation, you're probably not going to be comparing apples to apples. You might have a little bit different performance of your software instrumentation on different operating system platforms. And then, as I earlier mentioned about the touch sensor, so if you need to do things very accurately to the 10 micron level, robotics is really the only way to go. And a lot of this is hardware centric, but some of this also trickles down a little bit to the software layers. Some of you might have heard about the Google Chrome TouchBot. So it's a system we delivered to the Chromebook team over in Mountain View. And what it's used for is used for measuring the end-to-end latency of the user interface on Android and Chrome OS devices. So it's part of like a continuous integration system where the new firmware uploads are getting automatically into the devices. And as you can see here, there's like 5 units on the same robot. And you can fit another 5 there pretty easily. So all of these gets the new software built into it. And then the robot will go and activate the product, actually a little bit similar way what we have here on the demo. And we're looking for things like how quickly the display is responding to the actual physical touch. So there's like 2 systems. One is the one in the picture has like a 2-finger actuator, so you can do also pinches and zoom motions. And then there's another one which is actually the biggest robot we've ever delivered, which has 1-finger actuation, but you can fit much more units under it to get tested during the integration cycle. But then it's demo time, so this is probably what you've all been waiting for. So I'll just go let Natalia do her thing. Can we get the previous slide in there, please?
Yeah.
There we go.
Okay, so here is the demo setup visible there. So we have an actual small 3-axis robot here, and it's equipped with a brass fingertip for interacting with the device, and a high-speed camera to measure the latencies of the graphical user interface, and also a small camera for navigating the UI and for configuring the location of the device. And can we have the live stream now? OK, great. So our software, which runs on this laptop here, provides easy-to-use programming interface. So the user who will use this robot to test devices doesn't need to know about anything about how to control the robot or about robot's coordinate system. Once we have configured the location of the device, then we can just say that tap on a certain location or swipe across the screen or take a screenshot and verify that there's certain icon or text visible on the screen. And in this demonstration, we'll be measuring so-called pen-to-ink latency, which is basically the distance between the fingertip and the line that is being drawn while we swipe with the finger. And there are also several other types of UI latency measurements, like, for example, how long it takes for device to react when user taps, or how long it takes for example, for camera application to launch, things like that. But now let's take a look at this demo here. It's a very simple Python script which will execute 3 identical swipes on this device. And it will measure the pen-to-ink latency for each of the swipe, and then plot the results on the screen. So let's start. So first, the robot opens our test application, which basically just draws a line on the screen immediately after receiving the touch, after detecting the touch. And we could use any painting software. The reason why we're using this here now is that we can be sure that there is no extra latency coming from the app itself. And here we're using a simple Python script. We have tools for creating simple measurements like this without knowing any programming languages, but creating Python scripts provides better flexibility and better integration to continuous integration tools or test frameworks. So here we're just providing an API that is easy to use and can be integrated into anything. OK, and now we have the results. And probably can't see it, but it's the pen-to-ink latency for this device, which is Nexus 4, is around 80 milliseconds. And usually, anything below 100 milliseconds is considered to be immediate. So the results are pretty good. So good. And yeah, that's it.
All right. So is there any questions?
Thank you, Hans, Natalia, and Robot. Let me sneak across. So it seems like the first one is it fast enough, including movement, image recognition, et cetera, to be applicable to game testing?
Well, this robot here is really a low-end thing. So you can get more speed with Scala robots, Delta robots. The more problematic probably is going to be the image recognition part. We do have solutions for measuring frame rates, for example, directly from the screen. But detecting icons, and then it depends on how quickly you need to react to them. And at the end of the day, you can just build a server rack, behind it, and it's just math, pretty much.
Yeah,
but
it depends on the game.
Yeah, but with a laptop, it's probably not going to work right now. We'll wait for a couple of years.
Yeah, but we're playing Angry Birds and Clash of Clans with this robot. You can see videos online how this robot.
Yeah, please go to YouTube and search for Opto Fidelity. There's a whole bunch of fun stuff in there.
So how do you test your own testing machines are working?
That's a really good question. Well, we do characterize the robotics for accuracy and the timing with external equipment like optical encoders and things like that. I'm not sure if that answers the question directly. We're using ready-made libraries for detecting icons, for example, if the question is more of, are we getting false failures or are we getting false passes? So we come from the background for the company is from the image processing and machine vision. So we've worked with a lot of the image libraries for icon detection. But so we haven't implemented all of the algorithms behind it. We tend to more use the existing libraries.
Okay. It seems like this only makes sense financially to run in very high value scenarios. How feasible is it to roll
We just dropped down on it.
this out for functional testing? How feasible is this for functional testing for middle or lower finance or lower value scenarios?
Well, right now what we're seeing is that this is used for a subset of testing. The subset, the things that cannot be done with software, or the software version or software instrumentation is not reliable enough. The robotics is developing all the time, so the prices are coming down, the speeds are going up, and in the near future it might be financially more well, I mean, we're happy to provide all this stuff. That's not a problem, but right now it's probably just a subset, but we're going to wait for a couple of years, and I'm pretty sure there's going to be a lot of low-cost robotics. I mean, there's like 3D printers coming out every day, and all this development goes into the robotics, and we're kind of harvesting on that.
Great. I do have time for more. How is this robot controlled? Can it talk using Java? And how is the validation done across different devices? Like, do I need different scripts for different devices?
Yeah, so the API that we're using, it's actually HTTP. It's like a REST interface, so that'll work pretty much with anything. So if you want to use Java, that's perfectly fine. We provide like a Python library or a wrapper, and I think
C#, C++.
Yeah, so the interface is really simple, and then the tools for doing the configurations and like positioning the device and all that, those come with the system anyways. So the interface when you're building your scripts is really simple, and you can use pretty much whatever language you want.
What about reusing the same script on multiple devices? Say you have a Nexus 4 and a Nexus 10 that you want to run, say, that speed test on. That's
possible because we actually the icon detection that we're not using bitmap comparison on the icon or the OCR. So if the display sizes are different, even if the color scheme is a little bit different, it will adapt very easily. Obviously, you can write a script that doesn't work, but it's always a possibility.
Yeah, as long as the navigation logics doesn't change, then it should work.
And one last question. Are these robots meant primarily for development, or are they something that might be used for sampling of the entire production run?
Well, we have delivered robots for production of devices, of equipment. So we're using the same technology or parts of the technologies. It's not identical to this. So typically the type of things that we're demoing here, these would be on an R&D team would be interested in this kind of results. but we're using the same technology. We have some robot platforms that we use on production line, and the technology that we've developed. Some of these, like the actuations, like the fingertips, and the locationing of the device. We have automatic locationing. That is also used in production.
Well, thank you again to the two of you and your robot.
All right,
Thanks.
thank you.
Just so everyone knows, we have to pause for about 2 minutes to get this torn down. While that's happening, a few reminders. If you need to ask questions, even if you're sitting here, whether or not you are, pollev.com/GTAC2015 is your way to ask questions. Don't worry. If you don't take all your notes, whatever, we are posting the slides and the videos online ASAP after this conference is over. And if for some reason your question doesn't get answered, remember that the speakers are in attendance here. Find them during one of the breaks. See them during lunch. Sit down at their table. Talk to new people. That's what this is all about. So go say hi. Where is my next speaker, Dan? Come on up. So our next two talks are going to be pretty quick. So to get us started with our first lightning talk of the day, it's Dan Giovanelli from Google to talk about juggling chainsaws.
Hey, so robot is a tough act to follow, but I'll see what I can do. Someone had to. My name is Dan. I work at Google in New York as a software engineer in tools and infrastructure. Talk is called Juggling Chainsaws for Fun and Profit, and I'm here to tell you about some of the mistakes my team made building cross-platform mobile test systems. So like I said, my name's Dan Giovanelli. I primarily work on mobile, and my experience is specifically in iOS on a team called the Mobile Display Ads Testing Infrastructure Team, which from the name you might guess means we build testing infrastructure for mobile display ads. A little more specifically, our customers are other engineers who are working on a whole bunch of different ad products, display ad products specifically, all serving to mobile devices. So as a rule, if it has a screen and no keyboard, that's us. Phone, tablet, watch, all that kind of stuff. This basically means we have to build testing infrastructure for a bunch of different ad products serving through several different native SDKs on both Android and iOS. So when our team first got started about 2 years ago, we were sort of facing this really thorny problem, which is we had these engineers building very, very complicated backend stacks with a lot of different moving parts. And they needed to be able to test their changes to those stacks on mobile and make sure that they weren't breaking anything on mobile devices. Unfortunately, they weren't mobile devs. They were usually back-end devs, so Java, C++. They're not mobile experts, and they don't really have the time or bandwidth to become mobile experts. That was our job. And we had to avoid getting caught up in what we call the matrix, which Jürgen talked about a little bit in the keynote, which is basically this idea that you have multiple operating systems, multiple SDK versions, multiple device types, and you have sort of this combinatoric explosion of things you have to test that gets really out of hand really, really quickly. So what was our plan? We decided pretty early on that we were going to let our users write tests in this sort of non-mobile domain-specific language. Looked a lot like JSON. And you can see an example of one of those tests up there. Basically, they're data-driven tests. They lay out the most important parts of a test: what ad to load, what sizes to load it on, what to do with that ad. And then we, under the hood, ran those on mobile. We basically had our own pipeline to convert those to something that worked on mobile and run them, so our customers didn't have to worry about that. We decided also pretty early on to run on simulator. Just that makes the whole matrix thing a lot easier to deal with because you don't have to worry about having all these different devices. And devices are hard. They crash, they break, they catch on fire sometimes. That actually happened once. So we figured simulators was sort of the easier way to go. We wanted to make our results just really easy to understand and have clear action. So rather than saying something is broken, make it more, this is broken, this is how you should fix it. And as sort of a parallel request, our customers wanted a manual testing app. So basically an app that they could just, in front of them, as part of their development cycle, load up an ad, interact with it, see what happens, in addition to the automated framework. So how do we actually build this thing? Like I said, we had custom Python scripts to take those DSL tests and both what we refer to as unfolding them, which was taking one test and turning it into a bunch of tests across operating systems and all that, and convert it into intermediate formats that played nicely on mobile. So JSON for Android, and for iOS, a format called plist, which is a binary XML format that Apple and Apple alone uses. Surprise, surprise. We had custom Android and iOS apps that allowed for manual testing. Like I said before, the apps that could open an ad and run through them. And then those same apps were basically driven by those tests for automation testing. Those ran on simulator, and they were driven by Espresso on Android and an internal iOS functional testing framework for iOS. We had an App Engine backend that we used for storing golden images. So for testing rendering, you could compare an ad to a known good image, and it also stored some additional data for tests. We had internal Google systems for actually spinning up the simulators and interacting with them and getting data from them. But there was really nothing there that you couldn't build at home from open source parts. We just were lazy and used some pre-existing stuff for it. Internal pre-existing stuff, not open source pre-existing stuff. And we integrated with the existing Google tooling for building binaries and running tests. So basically, we could integrate very nicely into our users' development workflow. The same systems that they were used to for running unit tests and integration tests, they could just kick off these tests and get results back the way they were used to. There's a little bit of a diagram there that I won't spend too much time on. But basically, the stuff that's in the clouds is existing Google infrastructure. So we were able to kick off our system from that and then sort of hook back into it. So the braggy part, what went right? We put a lot of thought into how to avoid the matrix, and it pretty much worked. Between running on simulator and using that domain-specific language, our team had to worry about the matrix a lot, all the time, but it was completely opaque to our users. They did not have to care about how they were going to run across all these different devices, which was a major goal of ours. And on a similar note, our back-end developer customers really appreciated that they didn't have to know anything about mobile. They could write these JSON-y tests, kick them off from the systems they knew, get back results in the systems they knew. They really liked that. And it was a useful system. We had great adoption for both the manual and the automation components. We had a lot of metrics, and they said nice things. So now the fun part. What do we mess up? We thought a lot about these back-end developers who are going to be using our system. What we didn't think about was that the developers who were actually working on the native SDKs that we were building into our apps would also want these kinds of tests. And they wound up using the system too, but they wanted less abstraction. They wanted to be able to write tests natively, and they wanted to be able to kick them off from their IDEs. And unfortunately, because of how our system was architected, we couldn't really give them that. We couldn't integrate it with their development cycle, the native development cycle, and that became more of a problem as time went on. We also had a whole bunch of systems which should have been really lightweight that were sort of stuck together because as we were developing, we had the manual versus the automation. We had all these different SDKs, and we sort of kept stapling them onto the system until it became this kind of Franken system where whenever one thing broke, totally unrelated things would also break because they were closely tethered, and that caused unnecessary flakiness. We also didn't think through platform differences. We sort of thought from the beginning that we'd build things for Android, we'd build things for iOS, we'd provide them both. It didn't really work like that because they're very different platforms. And we wound up with things that were a little harder to implement on one platform, or things that were completely impossible to implement on another platform. And that sort of led to this problem where we had inconsistent feature sets. And you had tests that could only run on Android or only run on iOS. And that added cognitive load for our users who now had to worry about where their tests could run, which sort of defeated the purpose of part of the entire system. So what do I wish I'd known from the get-go? What did we learn from this? Subdivide your systems. It's really easy to think, oh, I'm building something that's sort of built on top of something else, so I'll just put it in there, and that gets you velocity in the short term, but causes all sorts of problems in the long term. If you think two things should be in different code bases, you're probably right. Ideally, you want to have sort of logically divided systems sharing common infrastructure. If any of you are thinking microservices, that's, yeah. The whole idea of the God object anti-pattern from object-oriented programming, where you have one object that does everything and nothing, that applies to systems too. It's generally just good software engineering practice, but it is important to keep in mind. The more things change, the more they stay the same. Know who your customers are and have a plan to give them what they want. And notice that I did not say know who you think your customers are and what you think they want, because you will be wrong. Take some time to go out there, talk to people who might be using your systems, get a sense of who they are and how to build what they want. And the answer may be there are going to be people who want to use a given system where it's really not the right fit. And that's a great thing to know at the beginning, because you can say, this is not the system for you, we'll build you something next, rather than them trying to use it and not being able to do what they want and getting frustrated. Don't ignore platform details. For any given feature, have at least a pretty clear idea of how you're going to implement it on whatever platforms you're using. And if it's going to be much harder on one than the other, have an idea of how to mitigate that. Maybe that means putting more development resources behind the harder one, or delaying release of one even after it's finished until the other is finished. Just have some idea of how you're going to address the fact that the platforms are different. Simulators are great in automation. They let you do all sorts of great stuff with sharding and parallelism. You don't have to worry about them catching on fire. You're always going to need some amount of real device testing. There are bugs that will only pop up on real devices. There are features that you can only test on real devices, so things like NFC or camera. But save that for manual testing. Anything that you can run on simulator for automation, you should run on simulator, in our experience. So that's it. Got 4 minutes left, so if there are any questions, I'll take those.
Can we switch to top view? Feeling. iOS automation is painful for everyone. Are you guys going to open source any of these internal tools?
So some of them already have been open sourced. There's a great tool called Martian that we use for proxying requests, for verifying network traffic and mocking out network responses. The people who built that and open sourced it are actually here at GTAC. So if you see Brahma Ghosh, say hi. Some of the tools we want to open source, but can't for various reasons, and some we want to open source, but it's a slow process, and it's in process, but when that'll happen, there are a lot of variables as to when they'll come out.
So what simulator and test tool set do you use to avoid a big lab of matrix of device, OS, browser combos?
So for the simulator, we're just using, like I said, it's mostly open source. So on Android, we're using the Android emulator. There are a few sort of tweaks to it that we've made, but it's the same emulator that you all know and probably hate. Same on iOS. It's the standard Xcode iOS simulator. We're using the just sim control tools in the latest Xcode versions to actually drive those. Before those were available, there were certain open source tools, libimobile device, stuff like that, that you could use for a similar effect. Yeah, and then it's just some internal tooling to sort of bring those together nicely. But like I said, it's nothing that you couldn't build at home.
I hope you can understand this question. How do you choose the devices to test for preventing being sucked into the matrix?
Usage metrics are really important. If you know that 0.01% of your users are running, I don't know, Jelly Bean on a rock somewhere, then that's probably not worth testing. Really, it's a really good question, and it sort of falls into the same bucket as don't assume that your customers are who you think they are. Don't assume that the devices are what you think they are, because you will be wrong, because maybe 60% of your customers are using Jelly Bean on a rock. So really just having good metrics around what devices your code is running on and operating systems and all that is really important for just knowing what to test on, and just as importantly, what not to test on.
And Dan, since you talk really fast, you get one more. Why did you choose to implement your own language rather than adding a library for something like Python?
So it actually is Python. Those are Python dictionaries, and we use Python scripts to turn them into non-Python. But basically, it's not so much that we declared our own language as much as you can sort of think of it as we declared our own schema. We said these are the elements of data that a test needs. These are the elements of data that a test can have but doesn't necessarily need. You structure that as a Python dictionary, and then we do the rest.
Thank you, Dan.
Thanks.
And next up, we have Yoko from Bitbar to talk about using image recognition for mobile app and game testing.
Hello. Okay, so my name is Joe Kasla. I'm the co-founder and COO of Bitbar, the company behind a pretty awesome online service called Test-Drive Cloud, which is it's a device cloud of Android and iOS devices from every single market in the world, including Japan, China, Korea, and India. We also host private device clouds for people who don't want to share their devices, and we license our technology to companies who build large-scale on-premise device labs. So in the next 10 minutes, I'm going to tell you how to get rid of 60 manual testers and replace them with one smart one. And this is actually something that has happened with one of our customer organizations. When they moved from 100% manual testing using real devices to 100% automated testing using real devices. And at the end, I'm going to have a gift for all of you in the spirit of the holiday season. So let's start. So if you look at the chart of the most crossing apps on the Android or the Google Play today, on the top 50 list of the most crossing apps, there is only one app that is not a game. And if you look at the top 100 most crossing apps, there are only 3 apps that are not the games. So it's pretty obvious who's making the money on the app stores. And usually games are free to download, and they monetize with in-app purchases. So it takes a little bit of time, or you have to engage the user long enough to make really any money on that. Because currently, the average customer acquisition cost, or the cost per download on Android and iOS, is around $5. So it means that you have to keep the customer for as many releases as possible in order to recover that $5 investment and make some profit on top of it. So it's very high motivation for testing in general and making sure that your game works on every single device out there. So given the commercial incentive, why hasn't this all been automated long time ago. These guys do have a lot of money. That's not the problem. So the problem is that mobile games are not really easy to automate. They are very difficult to automate. So the main reason is that the games use direct screen access in the form of OpenGL or ActiveX, and they effectively bypass all the operating system controls or services you have. So that means that any of the native mobile test automation frameworks that we all know can't really access any of the internal data of the game. So you only have to resort to X and Y clicks and reading the screen buffer. You basically have to test everything from the outside of the game. And of course, in terms of automation, that's pretty tricky. The second thing is that the games are very performance driven. So first of all, they consume a lot of resources. So the game binaries are 2 to 3 gigabytes today. They use a lot of network traffic. They use a lot of memory. They use a lot of CPU. They use a lot of GPU. They utilize the sensors. So it's pretty clear that these guys, they don't test anything on emulators and simulators. It doesn't just make any sense. And there's another interesting incentive is that one of our customers told us that if they can add one more very popular Chinese Android device on the list of their supported devices, it can bring up to 5 million revenues over the lifetime of the game. So you can invest quite a lot on optimizing your game on that model. So all the difficulties have actually led to this. So the guys have resources, and it's difficult to automate games. So all the gaming companies, the large gaming companies, have very large manual device farms on their favorite low-cost locations. And that, of course, leads, it doesn't scale very well. And that leads to another problem, that the QA process causes delays on the actual release of the game, which increases the time to market. And that's the real cost of the manual testing, that things get delayed and you don't stick to the schedule. And of course, even with games, there's still a lot of room for manual testing. But that space is more for the qualitative, testing of the fluidity of the gameplay, that sort of aspects, not to go through every single menu on every single language on every single device. That's the job for the automation. So the most typical assignment we get is that, guys, we only need to automate the basic basic functionality of the game, so on as many devices as possible, and it has to run as fast as possible because they want to automate it on every single build. And of course, with these guys, the challenge is never the access to the devices. For the manual testing, they have hundreds of devices. That's not a problem. The problem is that how to automate these monotonous routines, and especially in a way that they produce actionable results, such as performance data, logs, screenshots, and videos at scale. With manual testing, you can get those one by one, but you can't get it at scale. Another curveball is that, of course, these teams, they don't have programming skills or background on scripting, which severely limits the tools and the frameworks that can be used. And also, these guys these teams are usually quite separated from the actual development team. So any kind of white box testing or instrumenting the game itself is not usually feasible for these guys. These guys get the APK thrown over the fence, and it's pure 100% black box testing scenario. So with these two requirements in mind, need for very simple scripting without any computer science skills, and the pure 100% black box approach, we started looking at the open source space. That what sort of building blocks could we find to gobble up a solution that actually solves this this sort of problem. So as a foundation of the solution, we selected Appium. And the fact that Appium is cross-platform test automation framework works really well here, because usually the game is exactly the same on Android and iOS. So in ideal case, you can use the same script to run your automation on both Android and iOS. Also, Appium provides a pretty nice abstracted API that we can use for the next level of our automation to run. And in this scenario, we cannot use any of the advanced features of Appium, like the object inspecting the object and that sort of things. We can only use X and Y clicks and drags. For the next level, we had to kind of figure out three things. First, how can we know where in the game flow we are? How can we get that info? Then when we get that info, where should we click next? What is the next X and Y coordinate to click? And then after we have clicked something, did we achieve what we wanted to do? Did the game go to the next stage as we expected? So to drive the test execution from 100% from the outside of the game, we selected OpenCV image recognition library. So basically, we feed the library with screenshots and reference images, and it does like a pixel comparison, pixel matching. And when it finds the matching location, it will feed the X and Y coordinates to the Appium script that then executes that on the real devices. It's pretty. The OpenCV library is very good for this because it's customizable. It's resolution agnostic, which is really good on real mobile testing or like real device testing context. And it can even recognize images that are stretched or like somehow at an angle. So you can even test like 3D games as well. So the outcome is that there's only two simple tasks that the test automation engineers need to do. They need to cut the reference images and then change only like one-liners or like one line of code on to define what kind of click needs to be done when the reference is matching or when you get the coordinates. So then parallelizing this was quite interesting. So in the device cloud, like remote device cloud context, the Appium client sits on the remote machine, which is typically a developer workstation or a mobile or continuous integration server on the other side of the internet, where the devices are. And Appium creates WebDriver session from the Appium client to the Appium server, which is on the cloud, and then using that server, all the data goes over the WebDriver session, including the logs and the screenshots and all the control commands. And the way you scale this is that you just spin a lot of WebDriver sessions on the same remote machine, and you just keep running it. But that effectively renders the remote machine the bottleneck. And especially in our scenario where we run the OpenCV image recognition stack on top of the Appium client, and we're transferring very large screenshots all the time on all the devices, we really hit performance for wall on like 5, 6, 7 devices per remote machine. It didn't scale. We had to look for something else. So our solution was that we moved all the processing, the whole test execution on the server side. So we created virtual machine images that included the whole stack, including the OpenCV, the Appium client, and Appium server. And this virtual machine automatically connects to like just one individual Android or iOS device at a time. Then we can run a lot of these on one physical server. We can run as many of these as we want, and the server has enough processing power to do all the pixel comparison, all that. We don't have to transfer the screenshots over the internet, and actually it's actually made this very robust and very fast. So in a way, it's like Appium Grid on steroids, because it runs like 3 times faster than your normal Appium, and it's really really scalable And the end user doesn't have to worry of any of the how to spin these up and how to scale. From the end user point of view, it's like running one session. They upload just one script and it runs. You know, their online system scales all that execution for them. So we prepared a demo on how all this works in practice. So can we start the video? Okay, so that's a demo, and as promised, the gift, all the sample code, all the instructions, everything, you can get access to those at testdrive.com/GTAC 2015. Questions?
Sadly, we actually don't have time for questions.
Good.
Because you are standing between these people. Good. Well, yeah, and you're standing between these people and food.
Yes, and you can reach me today and tomorrow. I'm going to be here all day. So any questions on automating game testing or scaling Appium on the server side, just reach me.
Great. Yep. Thank you.
Thank you.
Two quick logistics announcements. I've had people ask, where can we find the slides and presentations after GTAC? The answer is developers.google.com/GTAC. It is also very likely, and I will make sure it happens, that we will post the Google blog when we've posted the slides and the videos. So that is there for you. Now, lunch. Oh my gosh, exciting. Just outside of Boston Common, in the common area, there will be lunch available both on this floor, and there's accessible stairs to go upstairs where we have table and chairs available, as well as another buffet of the same food, both floors. So go for that. If you have any dietary restrictions or limitations and you are wondering anything about the food, have any concerns or whatnot, please find somebody with a black lanyard. They are your link to finding the food that can actually feed you lunch. And with that being said, we will see you back here at 2 o'clock. Welcome back, everyone. How was lunch? I hope everyone is full and happy. And in that spirit, to make you hungry again, we have a cooking lesson from Tony Chang on how to make soup dumplings.
I hope we all had a good lunch because I was told that my presentation is put after lunch for a good reason. So my name is Tony Chang, and I'm a foodie. I mean, a test engineer from Google. Since part of my work is to influence test best practices, I find myself having to convince people with very different backgrounds, like engineers, engineering manager, developer relationship manager, and product managers, why we want to do component test. After repeating the basic test concept over and over again, I decided I want to make this more interesting. I'm going to use soup dumpling as an abstract example to demonstrate creation of end-to-end test case and then breaking them down into component tests. And did I mention I'm a foodie? A few years ago, I went to a really fancy restaurant and ordered my favorite food, the soup dumpling. Expecting something soft and juicy, I got something tough and dry. I went to the waitress and asked, "What is going on?" She shrugged her shoulders and said, "Sometimes good, sometimes bad." Shocked at her answer, I went to the owner. The owner is a lot more customer-centric and told her, "We are a high-end restaurant, and you need to make sure everything is of high quality before you serve." For those that is new to this food, here's the anatomy of soup dumpling. It's got really thin, delicate skin with soup and meat wrapped inside, usually served warm. The waitress took a pause and said, "I guess I can try one before I serve each plate." So each plate will need a test sample for her to try before she serves. Do you think this is going to work? At least it won't be horrible, but there are limitations. And I see at least 3. First, she won't know all the aspects to look for, so there's the lack of baseline. And then she's got limited stomach space. So if she serves, I don't know, a plate every 5 minutes, she'll get full really soon. So this is not scalable at all. And then, if she found something that's not right with the dumpling, the customer would need to sit there and wait for everything to be remade from scratch. So the turnaround time is way too long. Fast forward a few years, I'm now a test engineer. I exist to engineer efficient and sustainable tests. How can I help? Using my learnings from software testing, let's see what I'm going to do different. First of all, I will consult the spec. The spec will spell out the different requirement and criteria to look for, which will address limitation number 1. In software, we would have different documentations with varying different level of detail. Like the first column, the one-pager, has the really high-level attribute of what a soup dumpling should be like. And then in the second column, you've got the PRD, which spells out the use cases. And then in the third column, you will have the functional spec, which has the actual implementation detail. Let's use safe to eat as an example. If you would have been creating a manual test case, you can just go by the PRD, because your human tester has the cognitive ability to figure out whether something is cooked or not. Whereas if you're doing automation, you might need to spell out what cook means to define it. Just like when you're testing software, your human tester would have the ability to figure out whether a system has been booted successfully, whereas your automation will need to look for something more specific, like what events to look for, what event constitutes to a successful boot. In this case, your functional spec has defined cooked as 180 Fahrenheit, and your automation will be happy. So here is how your automatable test case could look like. Measure the dumpling when it comes out of the steamer, and make sure that it is 180 Fahrenheit or above. And then your spec also says your dumpling needs to look pretty. And it spells out pretty as 18 folds at the top. Your automatable test case could look like validate that it has 18, count the folds and validate that it is 18. As you can see, both of the test case no longer require you to actually eat the dumpling, so it addresses the limitation challenge, the scalability limitation. However, some of this could be difficult to validate. Say, for example, the soft and juicy criteria. The spec says it needs to be 30-70 soup meat ratio. In order to automate that, you need to first extract or validate that. You need to extract the soup, pull out the meat, weight them separately, calculate the ratio before you know that it has met that criteria. Can we do something better? Probably not with our current understanding, because we've been looking at the dumpling as a final product and have no insight into its production process. The best we know is you've got some raw material, do some auto magic, and then boom, you have your final soup dumpling. But if we understand the actual production process, we might actually be able to do better. So let's go through this briefly. First, you make a chunk of dough, divide it into little pieces, roll them into skin, and then put some meat in there, put some soup jello in there, wrap it up, and then steam it. After you steam, the soup jello will melt to become soup. That's where you get your soup meat ratio from. And if you fill in the detail that you've just learned about in this diagram, you will see that you will understand the dumpling creation flow a lot more. Does this resemble any of your software architecture diagram? And if you look carefully, you will see that there are a few major components in there. The first one is divide. It takes in an input of a block of soup jello and output the right amount for one dumpling. The divide component takes more than one input types. It also takes in meat and output the correct amount. Your next component takes in both the soup and meat piece and mix it into become filling. As you can see, each of these components have their independent input and produces the output that is expected from them. And if you iterate through the whole process, you will see that this is how the whole flow looks like. Each of the component has a clearly defined input and a clearly defined output. And testable software design also looks like this. They have well-defined components. And you ask, how does this help me? Well, remember that last test case where you need to isolate the soup and the meat and all that? Let's see if we can do better with component level validation. Now that you have your component isolated, you can see that the divide component is really the only one that contributes to this end result. If you can make sure that your divide component is outputting the right amount of soup jello and the right amount of meat piece, it's really highly likely that your end result ratio is going to be correct. So if you do a component level validation, all I need to do is validate that the soup jello is of X gram and the meat is of Y gram. The wrapping test case. Remember earlier you were counting the folds after it was cooked? Now that you have this diagram, you can easily see that wrapping the filling and skin is really the only component that has effect on this final result. So instead of waiting for the steam process, you can validate that it has 18 folds right after your wrapping component is complete. And as you can see, both of these test cases demonstrated how component level tests can greatly reduce the turnaround time and identify issues earlier in the development cycle. And the last test case, remember the cook test case where it needs to be 180 Fahrenheit? With the same diagram, you quickly identify that steam is the only component that is affecting this end result. While you can validate that it has been cooked to 180 Fahrenheit, if you look through it, think through it a little bit more, your steamer is not really your system under test. if you have a reliable steamer, you should be able to know that as long as you cook it for n minutes, it will reach the temperature that you desire. So your test case can be greatly simplified to make sure it has been steamed for n minutes. Think about it in software terms. If you're able to clearly define what your system under test is and not conflate it with all this dependency, you can also simplify your test case greatly to test for only what you want to test for and not anything else. Some people say, it doesn't work for my project. My project is too complicated for it to be divided up. Or others say, that's not really testing the end-to-end scenario. Or they said, if I test all the end-to-end scenario in the world, I can cover my components anyways. Well, if you look around, component testing is actually everywhere, even when before there is software. When you go to see how kids learn gymnastics, you will see that they repeatedly stick their feet out, just that. And their instructor would tell them to correct every minor movement of theirs. And after they got that part right, they would then connect it together to become a routine. If you play in an orchestra, for example, all the individual instruments will need to make sure that their part is fluent before they combine it to become a symphony. Or if you play soccer, your coach is going to ask you to drill on independent skills like dribbling, running, even though it's covered as part of the game. So I hope you see a pattern here. Any product that is of complexity, be it a physical product like a soup dumpling, or an experience like a symphony, in order to do it well, you need to break it down. Why do we think software is any different? If you're semi-convinced and want to think about implementing this, there's a ton of resource online about test-driven development, refactoring, testable design. You just need to look around and find what is right for you. And you ask, am I done with really good component level tests? Unfortunately not. Component test is really just a stepping stone to a finer quality. It is not a replacement of your end-to-end tests. Every once in a while, you do want to eat your soup dumpling, and every once in a while, dog food your own product. Maybe just not every plate, and not every change that you make. I hope this has given you a new perspective of seeing your own product, and next time when I use it, it's sometimes good, other times also good. Thank you.
So thank you, Tony. We have a few questions for you. Is a component level test the same as a unit test?
I would see unit tests as a type of component test, but usually if you want to define it more clearly, unit test is a little bit smaller test than a component.
To what extent is component testing dependent upon service-oriented architecture? Can you component test a monolithic application?
I think component testing is dependent on a design that will allow you to be able to test things in isolation. So I would say that it is highly dependent on how the architecture is and how it's designed.
Stop flipping. Sometimes your components have unexpected consequences. Say you change to a new decoration that sometimes punctures the dumpling and causes the soup to drain. How can you handle this?
I think stuff like this will be captured in the final validation in end-to-end test that you're not skipping. I think the point of component test is really to make sure that you're catching things early that you can test on component level and not replacing things that you absolutely need end-to-end test to uncover, like for your example.
How does this compare to the ACC methodology in the now abandoned Google Test Analytics project?
I am actually not familiar with the Google Test Analytics project, so sorry about that.
And I think we're going to call that the last question since we just have a few seconds remaining. So thank you, Tony.
Thank you very much.
And up next, we have Brian Gauguin talking about Chromecast testing.
Hi guys. So after all that talk of delicious dumplings and lunch, I'm sure there's some post-food coma setting in, so I'm going to try and make sure that I keep it fast. So my name is Brian Gauguin. I'm a software engineer, tools and infrastructure at Google, and I've been lucky enough to be working on Chromecast for the last couple of years. So I'm going to do a little bit of context setting first, just to kind of set the stage. For Chromecast, it's part of a wider movement that's going on in the industry about Internet of Things. So everybody's kind of aware of this. We have lots more devices being released onto the market, being connected to the internet and interoperating with each other. So this is a big test challenge for us. The numbers of devices are pretty big. Right now we're somewhere around about 5 billion devices in the market, and by 2020 that's expected to grow pretty hugely. So why do we care? Well, software really powers all of these devices. Typically there's pretty extensive software stacks running on these devices, and as we all know, software needs testing. So lots of opportunity for us. So Chromecast, just want to kind of give a background on Chromecast. I think most people hopefully know what Chromecast is, but for those of you that don't, it's a dongle that plugs into the back of your TV, and it allows you to stream content from the internet onto your TV. And that content can be movies, can be TV shows, it can be videos, it can also be music content or photos. So it's kind of a challenging device in several facets. In terms of Internet of Things and how it all fits together, it's kind of a good example of some of the challenges that we face. There are multiple devices talking to each other. In order to get content on your TV, you use your phone. So the phone is your remote control. Therefore, there is communication between the phone and the Chromecast device itself. So you've got a lot of asynchronous communication going on, a lot of challenging things to test. The device itself has been pretty successful. We've sold about 20 million of them. We've got over 1,000 apps in the market, which means it's more and more challenging for us to release new features and make sure that we maintain quality of the ecosystem. So I'm going to talk a little bit about test automation for Chromecast, talk about some of the challenges that we have faced, and kind of map out some of the future work that we have, not just for Chromecast, but for Internet of Things in general. I'm going to focus mostly on device testing because that's kind of probably the most fun stuff that we do. But one question that always pops up is, do we use emulators? And the answer is absolutely. Virtualized devices running in the cloud, it's a scalable solution, allows us to do end-to-end testing from, for example, Android phones to Chromecast devices. We put some plumbing together to make sure that they can communicate with each other, and then that gives us a very nice, clean, hermetic test environment. So you get a lot of benefits there, like flakiness elimination. And it's scalable in a couple of senses. One, it's scalable that you can just run, as many servers as you have in the cloud, you can run tests. And then also, it enables internal partners that we have at Google, like YouTube, Play, Photos, to use that infrastructure in their end-to-end testing. So then the question comes up, why would we test on real devices at all? So there are classes of tests where you just have to test on real devices. For example, performance benchmarking, interoperability testing. We have stacks of AV and DRM on the device that we can only test on the actual hardware itself. And there's certain types of bugs as well and issues that will only be found on the device. Largely, these are kind of timing-related issues. So the challenge, though, is getting a very good, solid signal-to-noise ratio from your test results. We have a lot of hardware variability, a lot of network variability, and the end result of that is that we have a problem of device management that we need to solve. So I'll talk a little bit about some of those challenges. First of all, our device lab for Chromecast, just kind of put some numbers and context behind it. 450 devices we have under test. That kind of spans the range of different cast-enabled devices that are in the market, including Android TV, Cast for Audio, and the various different generations of Chromecast. Lots of builds coming out per day, millions of test runs, all that good stuff. Lots of Gangnam-style playbacks. We contributed pretty heavily to that. So managing all the devices, what we did for this was to build a tool, our device manager. Now there's quite a few different tools at Google kind of working towards solving this. We found we had to build one ourselves for a couple of reasons. One, we have some pretty custom setups, which the other solutions in the market or at Google weren't supporting. The other one is that the grouping of devices, we have fairly specific groupings of devices that are necessary for specific types of tests, and we needed to be able to support that. So that's just, you can kind of see there the UI of what the device manager looks like, kind of gives you an idea. So what this device manager does is when a test starts, this manager acts as a broker. It allocates a device to a test, and the test will run on that device for a specific period of time. In terms of stuff that goes wrong, lots of stuff goes wrong. Kind of basic, obvious ones are, we don't have enough devices to run tests, so standard capacity issue. We kind of solved that by throwing more hardware at the problem. There's also the variation of test results across devices. We found that there were, even between different revs of the hardware, we would find varying results. So that was really tricky to kind of debug in some cases. We kind of built a lot of traceability of devices into the system so that we could really nail down exactly where differences were and isolate issues. Stuff that goes really wrong, unreliable devices mainly. We've a lot of hardware in the loop, and hardware likes to fry itself or overheat. It likes to disconnect from the network for arbitrary reasons. We also get stuff like kernel bugs, which mean it's really hard to recover the devices. We've also had cases where the MAC addresses of the devices just changed for arbitrary reasons, probably breaking some IEEE rules. Just happens. So countermeasures there, lots of monitoring, lots of logging. Redundancy as well. We threw a lot of hardware at the problem so that if a device does go down, we have redundant backups. And also, before we allocate a device for a test, we'll do some kind of basic sanity checks to validate that this is a reasonable device to use. And then, kind of one of the worst case scenarios that we sometimes run into is the bad build effect, where a device gets a bad build and it breaks the device, and this becomes a pretty virulent cascading effect and pretty quickly takes out the entire lab. Really painful, horrible stuff. You've got to go in there and recover all these devices manually. Not fun, especially when you've got hundreds of devices and trying to trace down the ones that are actually broken. So we've kind of established a quarantine system. Before we push builds onto a wider population of devices, we will push them onto a smaller subset of devices, which are kind of our taste testers of sort. So I think just kind of to summarize in terms of the tooling requirements for just general device management and Internet of Things testing. So device allocation and brokering mechanisms, that's kind of a given. We also need a system to be somewhat device type agnostic, as we're working with various devices interoperating with each other. And plenty of monitoring. Monitoring is super important. So the other kind of major challenge that we face with Chromecast is Wi-Fi. So I'll talk a little bit about some of the challenges here. So the requirements for a good Wi-Fi system or test system are kind of somewhat, counter to each other. Obviously, you want a reliable test signal. You want to isolate away any Wi-Fi interference so that the test is somewhat robust. At the same time, you want to have some level of controlled interference so that when you do run a test, it's actually exercising some of the logic that's on the device for robustness. At the same time, you want to do that in a realistic end-user environment, which is somewhat challenging to generate in a lab. And at the same time, you want to test across a whole bunch of APs. There's hundreds of APs out there that people are using. And then the kind of holy grail is also to be able to reproduce Wi-Fi issues that happen in the field. That's kind of an overall industry challenge that we have. So like I say, some of those may be mutually exclusive. So our strategy really for attacking this problem has been to implement various different test beds. We have test beds for these various different environments, and I'll just kind of quickly walk through these. First one is, these are RF isolation boxes that we use. In our test lab, one of the challenges that we have is the Wi-Fi interference from, various other devices that are around. So even if we just have a test running on a device in the lab, it's probably going to be super flaky. So we put the devices into these boxes. These provide about 80 dBs of attenuation and give us somewhat of a clean test signal. One of the cool things about working at Google is that we have lots of other teams kind of solving similar problems. So the Chrome OS guys have done an amazing job in putting together an interoperability environment where there's 150 plus of the most popular APs on the market in a fully automated setup. So we can drop in our Chromecast devices into this environment. The APs are turned on one hot, so you can communicate with just one AP at a time. And this is what we use for setup testing, for example, on the Chromecast to make sure that it interoperates with these various different APs. This has turned out to be, probably one of our cornerstones of our entire test strategy for Wi-Fi on Chromecast. Let's see. Another kind of environment that we have, so this is less on the automated side, more on a manual test side, is a set of shield rooms that we built. So these are effectively Faraday cages about the size of an office. So we have people in there testing. We have some amount of automation that we do in there, mirroring specifically where we are mirroring from an Android device to a Chromecast. That's a pretty, as far as Wi-Fi is concerned, that's a pretty challenging setup. There's multiple streams going from device to device. So a shield room is very, very useful there. One kind of interesting stress test we can do in there is we start off a mirroring session and then slowly open the door and just watch the mirroring session degrade. It's kind of fun to watch. Another kind of more recent addition to our lab is this Octabox. So this is our effort towards a very controlled environment. This equipment gives us a couple of different levers. One is an attenuator, so we'll put a router in one of the chambers and the device under test in the second chamber, and we can vary the attenuation in a very controlled manner. It also has a multipath emulator, which kind of simulates the real-world interference or real-world echoing that happens in a room from an AP to a device. And it also allows us some level of interference generation to inject that into the box. So this is, we do some level of automated testing in this, but it's primarily, an experimental setup, which kind of allows us to kind of solve, when we get a new Wi-Fi driver to validate that the quality is there. And the final one that we kind of set up is an emulated network environment. So this has been very useful, for example, with mirroring, where we want to have a very controlled set of environments where we inject a lot of latency or packet loss, and it gives us, good metrics on the quality of the mirroring session. So the device lab, I have some photos to show. When I was talking a little bit earlier about, if we get a bad build on a bunch of devices, it's pretty painful to go through. So here is the ugly previous situation. So you can imagine trying to find device number 22 in that mess. Not a lot of fun. We kind of had this ugly beast of a thing, which we anthropomorphized into an animal we call Casty, nasty Casty. So we spent a lot of time on designing a better setup, and this is kind of what we have now. So lots of, neat features here. A couple, like obviously we've got nice labeling, so you can figure out which device is which. It's all logically laid out. Cool thing here, you can see on the second from top shelf, you can see that we have switches there. Those switches allow us to view the HDMI output of any of the Chromecasts on the rack. So each rack holds 72 Chromecast devices, all running continuous integration testing. Close up there, you can see some of our Gen 1 devices. So you can see how the HDMI connection is there. So that's routed under the shelf and then up to the top screens via the switches. Here you can see kind of the backside of it where we have Ethernet connectivity to all the devices. So that's one other point to note, that all these devices under test are hard connected via Ethernet, which obviously cleans up, makes for more reliable test results. Here you can see the serial connections coming from the bottom of the devices. We have a class of tests as well that require HDMI sinks to be connected to. So it's kind of fun to watch tests running on all these different screens. Here you can see our next generation Chromecast devices connected up. So I have some quick photos of the build out of the lab rack. We kind of came up with this concept, sourced these components, and kind of built out the lab rack as was. So we started off with some cardboard, went from here all the way to a fully fleshed out prototype, and then started building it up on a rack, and then ended up with what we have today. So opportunities. I think, in and out of things, like I say, it's a nascent area, especially as far as test engineering is concerned. I think there's a lot of us in this room here who are working on various different approaches to this, but I think it's fair to say that there's no broadly adopted frameworks in the market at the moment. So lots of opportunities for testing in the cloud, for virtualization, interoperability labs. We have emerging standards coming out with Thread, Weave, and various different standards like that. So there are, there is convergence happening, but kind of like I say to my team, we have probably decades of work ahead of us in order to solve these problems. So that's it.
Thank you. And sadly, we don't have time for questions after this one.
I use it all up.
Yeah, he decided to use it all up, showing us awesome pictures. So next we have Shavik Rai Chowdhury, who is going to talk to us about, and I cannot remember the title of it. There we go. Using robots to test your Android app. So take it away.
Hi, everybody. This is my second time at GTAC. Last time I led a roundtable discussion on cross-platform mobile testing, and now this time I'm glad to come back to talk about using robots for app testing. So so one thing, right? So I'm going to talk about software robots, and not like the OptoFidelity guys who showed a real robot, right? So a disclaimer at the start, and let me tell you a little bit about myself. So I got my PhD from Georgia Tech in summer. My thesis was in the lines of how to do better cross-platform testing and maintenance for web and mobile applications, right? And over the past few years, I've been lucky enough to work at several companies, got a lot of industry experience, and in the past 1 year, I have been taking part in the different entrepreneurship programs at Georgia Tech, and that has led me to CheckDroid, which is an early stage startup. So if you have any inefficiencies that you guys think in testing, reach out to me, find me during the break. So today's talk will be mainly focused on presenting results from this research paper that we wrote, right? So automated test input generation techniques for Android. Are we there yet? That's a question that we are trying to address in this paper. And my collaborators for this project were my advisor, Dr. Alex Orso, and Alessandra Corla from IMDS Software Spain. This paper will be presented in 2 days in Lincoln, Nebraska at the ASE conference. Okay, so we want to use robots for testing, right? Now, but let's first see how a test structure looks like. So we all are familiar with this, right? Test structure has 4 different steps. At start, you'll have the setup phase where you'll initialize your environment and get it ready for testing. The next phase is the exercise phase. And what you do here is that you interact with the app, provide it inputs, and exercise it, right? In the next step, which is verify, you will check whether the app came in expected state or not as a result of the inputs that you gave it. And final step is the tear down step, where you clean up the environment and get ready for the next test, right? So how will a robot or an automated technique do these steps, right? So let's say we have a robot. For the setup phase, it can say that, okay, let me start the app, right? Let me install the app on the device and let's start it, right? For tear down, it can say, let me stop the app and uninstall it, right? For verify, it says that, okay, let's have an oracle or a policy that the app may not crash, it might not show any issues that you can identify. But the most important or the most challenging thing for such a robot is what input should it give the application, so that it could meaningfully exercise the application, right? And this is the main focus of this talk, where we are going to evaluate existing input generation techniques, right? So let me first introduce you to the simplest, and maybe most of you should already be familiar with the Android Monkey tool. So who here has used the Android Monkey tool? Many of you, right? So this is a tool which comes as a part of the Android SDK. If you have the Android SDK installed, you should have this tool. And you can invoke it using ADB shell, right? So you can say ADB shell, give it the package name for your app, and give it a number of events, let's say 500, right? And what it will do is it will just pick random events and throw it at your app to invoke it and to make it do different things, right? And this tool also has some advanced options, right? So since it's using randomization, you could set a number seed for the randomization, right? You could also throttle this tool, right? You could tell it that, okay, between different events, give this much, timeout, or give this much, wait for these many milliseconds. You could tell it that, when choosing the different events, right, focus more on this kind or this category of events. So you can give a percentage distribution. And by default, this tool will stop after it finds the first issue, right? So you can tell it to ignore issues like exceptions or timeouts and so on, right? So this is one example of a robot, right? And we looked at academic papers and industrial tools and found that there were several such tools which were out there in research papers and in blog posts, right? So we wanted to see how do these tools compare against each other, right? And is there need for additional research yet, right? So that's the question we asked. For these test input generation tools, have any of these tools solved the problem, and are we there yet? So that was the question we were asking. And while doing this study, we considered these tools as robots, right? So we considered them as push button techniques. You give this tool your app and start it, and it should test your app and give you all the problems that your app has. Right. So let me clarify a little bit the goal of testing in general, right? So goal of such a robot would be to make the app crash, and also to exercise the different behaviors that are there in the app, right? So if the robot exercised a particular behavior or a particular functionality of your app, and if it could not crash that functionality, then you have at least some level of confidence, right? So and for this, typically coverage is the weight or a proxy to measure this kind of a thing. Okay, so now each of these tools, is different from the other based on the strategy it uses, and I'm going to show you 4 things that actually form the tool strategy. The first is the instrumentation strategy, right? So each tool has to interact with the app and know or understand what happened as a result of this interaction, right? So the tool might modify the app by injecting probes in it, or it might modify the platform to know what's going on in the platform, right? So this is what I mean by instrumentation strategy. The next one is that, does the tool interact with the application only through the UI, or does it also send system events? So for example, parts of your app might be triggered via external notifications or via SMSs, right? Let's say your system gets an SMS and your app is listening to that, right? So in order to trigger such functionality, you will have to send these system events, right? So in order to see which tools do what. The third one is, does the tool require the source code of the app to do the testing, or can it do it in a black box fashion, right? And the fourth, or the most important strategy, is the exploration strategy, right? And this decides how this tool is going to explore the state space of the application, right? And I'm going to cover this in more detail, but there are 3 such strategies, right? Random, model-based, and systematic. So let's dive into this a little bit and look at the different exploration strategies that these tools have. So the first one is random, right? So here it's just like rolling a dice and picking a random number, right? So these tools, the tools in this category, Monkey and DynoDroid, what they do is they randomly select events and they just throw it at the app, right? So the good part about this is that you can do this efficiently, right? You can randomly pick so many events and throw it at the app, right? However, and also it makes it very suitable for stress testing, because you can see how well your app behaves when so many events are thrown at it, right? However, the problem with such techniques is that they are hardly specific. You can hardly tell Monkey that, okay, Monkey, make my app go to this particular activity or this particular state, right? So they are not specific. they are not agnostic. They are agnostic of the behavior, right? So if you have already covered some functionality, you will the tools don't consider that, and they might have redundancy in the events that they supply. They might be testing the same thing again and again, right? And finally, these tools have no stopping criterion. They don't know, have they tested enough, right? So typically, as I showed in Monkey's case, you give it a number of events to fire, right? Other approaches could be to have a timeout, like let's say, test my app for 1 hour, right? And then tell me what all you found, right? So this is about the random exploration strategy. Now let me talk about the second strategy, which is the model-based exploration strategy, right? So these tools, what they will do is, as they are exploring your application, they'll build a model of the application, right? And this model is typically GUI-based or GUI-based model, which can be an example of this model is shown on the right-hand side for the dialer application, right? So this is a graph-based model where the states are different GUI screens, right? And the edges are transitions or actions that you do in these states to go into another state or screen, right? So the tools in this category are A3E, SwiftAnd, GUI Reaper, Puma, and Orbit. And intuitively, these tools are more effective because you know what they are testing. And these tools are also less redundant because once they know that, OK, I've reached this activity, right, and I've seen it before, I don't need to test it again, right? So they are less redundant than random tools. However, these tools only consider the GUI state space, right? They don't know what is going on behind the GUI, right? So they cannot model them. They currently don't model them in the model. Okay. Now let's look at the third category, which is systematic exploration strategy, right? So these tools, what they do is they use sophisticated techniques like symbolic execution or evolutionary algorithms to systematically cover the state space of the application. So the two tools in this category, Active and EvoDroid. So for the first tool, Active, it uses symbolic execution. What it means is that it collects constraints from within the application when it's executing. So for example, on the right-hand side, you can see a constraint which is on the X and Y coordinate that the tool has to click, right? So once it gets this constraint, it can pass it to a SAT solver, get some solution for this constraint, and use that to test, right? Once you've tested this path, you can flip this condition to get other paths, and you can test other paths, right? So this is one way these tools operate, right? And the good thing about these tools is that they can systematically explore, right, more than, and they can, you can direct the testing towards one particular path, right? However, because in these techniques are, heavyweight, they are less scalable than random, right? So these were the three different exploration strategies, and we considered a subset of the tools because the other tools they were not available, right? They were only in a research paper, but they were not open source or available for testing. And some of the tools were focused only on testing a very specific part, right? And they were not general enough. So as I show in this table, these are 7 tools. Monkey was is from Google, right? The other tools are academic tools: Active, Dynodroid, A3E, SwiftAnd, GUI Reaper, and Puma, right? The second column shows if the app or tool needs instrumentation or not. Does it modify the app or the platform, right? And as we can see, Monkey does not, and Puma, which is the last tool, it does not modify anything, right? So Puma uses the accessibility API, and through that it can know the status of your app. Whereas Active, that tool modifies both the platform and the app, right, to get the symbolic constraints. Dynodroid modifies the platform, whereas the other 3 tools modify the app. As far as the next column shows, what are the events that the app supports or the tool supports, right? So all the tools support UI events. They can interact with the application through the GUI, right? Whereas only 2 tools, Active and Dynodroid, support system events. I explained the exploration strategy before, right? So as you can see in this, 2 tools, Monkey and Dynodroid, are random tools. A3E is systematic, and the other 4 are model-based tools, right? And out of all these tools, only Active needs the source code of the app. All the other tools can operate in a black box fashion. So now that I have introduced you to these tools, let me tell you about our experiments and how we evaluated these tools. Right? So for doing our experiments, we had 4 research criteria. The first one was how easy is the tool to set up and use, right? And the second criteria was, what are the different versions of the Android framework that these tools support? The third one was, how much coverage can these tools achieve on general subjects? And the fourth was, what is the fault detection capability, or can these tools reveal failures in applications, right, automatically? So for our experiments, we used 68 open source subjects. All of these were used in some or the other tools' own evaluation, but we considered a union and even more subjects, right? And as you can see, this shows the distribution of the subjects and the categories from Play Store. So for our experiments, we ran them on a Linux Debian machine, right? Since we wanted to have repeatable experiments, we used virtualization technology. We used VirtualBox for that, and Vagrant to control the VirtualBox. On top of this, we had a Ubuntu guest on which we had the emulators running, right? So for our experiments, we chose 3 versions of the Android emulator, 2.3, 4.1, and 4.4. And this was because some tools were specific, you wanted specific versions of the Android emulator, and KitKat was the latest when we did this experiment. So what we did was, on the Ubuntu guest VM, we installed this tool. We removed any default timeouts that these tools have, so that we wanted to run all the tools for a specific time, right? And we used their default configuration, which means that we did not tune any specific tool to avoid bias. So now now that I've shown you our experimental setup, let me show you how we did this experiment, right? So what we did was, we took each tool, and for each benchmark we ran it for 1 hour, right? Then we, since there can be non-determinisms in while running the Android SDK, right? Things can crash, things cannot behave in a deterministic fashion. So to account for these things, we ran these experiments 10 times and ignored anything that was outside the standard deviation, right? Results. And then we collected reports, right? So for the results, we collected 2 things. The first thing was, every 5 minutes we collected the coverage report. How much did the coverage improve over time? That's what we collected. And we also collected the logcat, or the logs from the device from which we extracted failures. Okay. So specifically, what we did was, we used the default EMMA tool. And EMMA, if you know, it does not give you statement by statement level coverage information by default. So it's present in the HTML reports. So we extracted this information from the HTML reports. And for logcat, what we did was, we wrote a custom parser based on regular expression, which extracted unique stack traces, right? So we wanted to have unique stack traces to find different failures. And we verified these manually to make sure that our parsing logic was correct. Okay. So now let me show you the results, right? So for the first 2 research criteria, ease of use and Android compatibility, we manually set up these tools in our infrastructure and evaluated them. So as you can see, 2 tools, Monkey and Dynodroid, required no effort. That was because Monkey comes as a part of Android SDK. We did not have to do anything, right? In the case of Dynodroid, the authors actually released a virtual machine. So it was very easy for us to reproduce and recreate their experiments, and we could easily use the tool. For 2 tools, A3E and Puma, we had to spend a couple of days to fix minor bugs, and we got them running. For 3 other tools, Active, Swiften, and GUI Reaper, it took us weeks to interact with the developer because these tools were not maintained anymore, but we finally got them running. Right. As we can see on the 3rd column, Active and Dynodroid, they both of them modify the framework, right? So however, they have a tight dependency on the framework version, and the version they provide only works for Android 2.3 Gingerbread. Swift Hand supports Android 4.1 Plus because that's what it was built, and Puma supports Android 4.3 Plus because it uses the accessibility API, which was majorly enhanced in 4.3, right? And 3 tools, Monkey, A3E, and GUI Reaper, can work on any version of Android. Okay, so now let's get to the coverage results. So this graph shows you the coverage, the distribution of coverage, for across all the different apps for all the different tools, right? So as you can see in this graph, for some applications, most of these tools were able to get high coverage. but the median is very different, right? So for example, both Monkey and Dynodroid have high median values, whereas the last 3 tools have very low median values. So let me show you the next result, which shows you the progress of coverage over time. So this graph shows you, how the coverage improved over time. So as you can see, in the first 5 minutes, all the tools were about to, we could quickly get, about almost, their max coverage, which is 40% coverage, right? So this shows that even if we had run this experiment for another hour, it would have still been flat, right? So it wouldn't have improved the results drastically. The only exception here is the pink line, which is the GUI Reaper tool. What that tool particularly does is it creates VM snapshots at intermediate steps, and it restarts the application from those snapshots. And that's why, because of this continuous restarts, it takes a long time for that tool to reach its max coverage. Okay. Now let me show you the next result. So this shows the mean of coverage across all the different tools. So as you can see, for some apps, all tools could get 80% or 90% coverage, whereas for some apps, they got really less coverage, but most of the apps were in the middle, right? So we wanted to understand why. And we saw that on the right hand of the spectrum lied very simple apps. Some of these were samples from Google, right? And they had a very limited state space. So all the tools could get decently high coverage on them. On the left side of the spectrum were tools or were apps which required, for which none of these tools was able to cover enough state space. We looked at these apps and found that these apps required a lot of manual configuration. So for example, the first icon there represents K9 Mail. It's an email client. It requires you to set up an email server, set up that configuration, right? And for our experiments, it was not possible because it's an external dependency that we have to reset after every experiment. So, but we found that this was a great learning that for such tools, it is harder to test them by any of these automated robotic testing tools. Okay. So now let me show you results from the fault detection ability. So here, what we did was we counted the different failures that were invoked by these tools, right? And as you can see, the failures are colored, which means which shows the different packages they belong to. For example, the blue color represents the java.lang, and one representative exception in that package is the null pointer exception, right? So as you can see, in the case of Monkey, it could get a lot more java.lang exceptions, right, than other tools, right? Whereas for a tool like Puma, it got java.io and java.lang, right? And the pink colored exceptions are the custom exceptions, which were defined in the app itself, and only 2 tools, which is Monkey and Swiftland, could reveal those exceptions. So we also wanted to compare these tools pairwise, which means that each pair of these tools, and the next graphic is going to show you that. So in this chart, above the diagonal, you see the coverage results for every pair of tools. Below the diagonal, you see the failure results for every pair of tools. And let me explain this a little bit more detail. So let's look at coverage. So here you can see that 2 tools, Monkey and Dynodroid, they had 43% of statements were covered by both of these tools, right? Whereas 5% of statements in the subject applications were only covered by Monkey, and 8% were only covered by Dynodroid, 9%. Similarly, for the failures, as you can see, 6 exceptions or 6 failures were common between GUI Reaper and A3E tools, whereas 40 were invoked by GUI Reaper and 24 were invoked by A3E. So now that I've explained you this, you see in the overall graph that in the statement coverage, we still have there's a lot common between the tools, right? But there is a lot more that needs to be covered, right? Most of these tools just reach 50%. And for the exceptions, as we can see, there's very less common between the tools. So you need more than 1 tool to expose those different failures, right? So our first observation is that random approaches seem to be doing their job, right? Random approaches seem to be effective in this context, right? Dynodroid and Monkey both did well, right? So let me now present you our findings, which I'll split in two different categories. The first is best practices that we saw in some tools which made them stand out, right? And limitations that we saw in tools that none of the tools implemented these practices, right? So let's talk about best practices. So the first thing was that tools like DynaDroid, what they did was they sent system events, right, which can, for example, SMS, right? So if your app is listening for SMSs, you wouldn't reveal any failures in that part of code unless you send a system event to it, right? So this was a very good feature of those tools. Then, as I mentioned to you, the tool GUI Ripper took a long time to get its max coverage. So for efficiencies, tools should minimize the restarts in the applications that they have. This is a very common problem for robotic crawlers, right? So what these tools do is they get stuck whenever they see a screen like this, but because a robot will not know what to enter here, right? So specific tools like GUI Ripper and DynaDroid, what they did was they allowed in the configuration you could specify the different username password pairs, right, or different values that the robot could then use and get past such screens. Right? Then an application's the behavior is dependent on the start state. For example, for the mail client, if there is no email messages in its content provider, it will not expose any behavior, right? So tools like GUI Ripper allowed the specification of different starting states by loading the app in that particular starting state, right, and letting the tool run after that. And the final one is that in our experimental infrastructure, we use virtual machines, right? So we could clear everything after the experiment. But some of these tools, what they allowed for is a partial cleanup, right, of uninstalling the app and clearing its data, right? So we thought that was also a very good feature in these tools. So now let me talk about some limitations or future work that these tools need to improve on. So the first one is reproducibility, right? So a robot might make your application crash, but it's very hard to actually look at the robot's log and to figure out what did it do to crash the application, right? We believe that such things should be a part of the tool's output, right? It should give you a test case, ideally, that you can run to reproduce that kind of bug. And we thought that none of the tools had this. The next thing was that since when you're testing, you always test in a hermetic environment, right? And none of these tools allowed for you to specify mocks, and they all interacted with the real systems. The third one was that while you're doing testing, there can be some harmful operations. Let's say you're testing the Uber app, you might, if you're not testing it in a right fashion, you might actually order a real cab, right? Or you might send out emails or SMSs, right? You don't want to do that. So none of these tools allowed for sandboxing, right, to avoid these side effects. And finally, we all are familiar with this picture, right? So there was no robot or no tool which was focused on finding issues that are across different devices, right? So none of them were targeted towards cross-device testing. So in summary, what I showed you was, I motivated the fact of how you can use a robot to do the testing. I showed you different exploration strategies that current tools use, right? I showed you details about our experiments and the results. And I've showed you some best practices and limitations in existing tools. So all our the virtualized infrastructure is available at this URL. You can also go to my website, shovik.com, and get a link to that. So that virtual machine has all these tools installed already with all the subjects that we used. So you don't have to go and build these tools from source. You can just get this and use it in your projects. And that brings me to the end of my talk. Thanks.
Thank you. I think we have time for a few questions. So first off, do you have any recommendations for iOS robots?
Yeah, so there is a tool called UI AutoMonkey. It's available on GitHub. It's the counterpart of Monkey for iOS. It uses the UI Automator API, right, that iOS has. So you could use that.
These tools may be able to find app crashes, but how do you then come up with a repeatable set of steps that can reproduce the problem and help find a root cause?
Yeah, so this is actually the hard part. So for example, in Monkey, you can ask it to be verbose, right? And Monkey will tell you that, okay, it did these steps, right? And then you see this exception, right? So what it means is that you have to go through all these steps, and you have to find a minimal set of steps, right? You have to reduce this to a minimal set of steps that can help you, find that problem, right? So this is actually a very hard thing, and we are working on some of these areas, right, to generate test cases. But yeah, so there's currently no easy solution for this.
Can you propose a new way to compare the quality of tests generated by these tools beyond those of coverage and crashes?
So, so coverage and crashes, of course, I showed it. Another thing is that, okay, your test cases, right? If you have, you should have a minimal set of test cases that can generate, the same errors, right? So let's say if you have 100 test cases that give you 5 errors versus you have 5 test cases that can give you 5 errors, right? So these tests, and of course the same coverage as well, right? So having a minimal set of test cases is also something that people, look out for, because then you can run these test cases fast, right, instead of running redundant tests.
Cool, and I think that's all we have time for, so thank you very much.
Thanks.
I just want to make one quick note. I do see lots of coats on, and I've been told multiple times it is cold in here. Facilities has been notified. What that means, I do not know, other than that they have been notified. With that being said, we have one more talk before our next break, where you can go warm up. And this is Alistair Scott talking about a very sensitive subject.
Thank you. Hello there. I'm going to be using the F word a lot in this talk, like a lot. I apologize in advance if I offend. You all know the F word, don't you? It's also known as the F-bomb. We test engineers use it all the time. Yes, that's one. Flaky. So last year, I went to GTAC in Kirkland, and like a lot of other people there, I was very shocked by the language. Every second talk was dropping the highly offensive F word. Over lunch, we were jokingly calling it Flaky TestCon 14. There were lots of talks about how to reduce it, ways to minimize it, and what to do when you have a flaky test. Flaky tests are something that most of us experience almost every day in our lives. They cause us no end of despair. And we should be afraid, very afraid. The concept of flaky tests has the potential to bring our testing profession down. There's been lots of solutions proposed around test design and test resilience, but we continue to suffer from this problem. The solutions don't work. As the F word gets dropped more and more, people start to doubt whether any tests are reliable and if testing's worth it at all. What if testers are flaky like their tests? We need to kill the term flaky. So I got back to work after the conference, and I was sitting at my desk, and I overheard a developer dismiss a failed build as, "Oh, that's just some flaky tests." I was shocked. I was shocked and offended. The F word, an excuse to ignore testing. People were talking about our work, and they were using the F word. So I swore to myself from that moment forward that I would not dismiss any issues as flakiness. I would stop calling our tests flaky, but if our tests aren't at fault, what is? Our applications. You see, flakiness implies that it's a test problem. and that no one needs to worry about it from an application development point of view. But what if it's not the test problem? What if it's our app's problem? Developers had started to use the term flaky to describe any failing test. Imagine how useful a flaky smoke alarm would be. It would go off very often, and you'd be like, well, that smoke alarm, it's just flaky. Let's just ignore it. You may as well not have a smoke alarm. You may as well ignore all testing. Why have testers? Why have test engineers? And like that, our profession became under threat. So how do we get to the bottom of flaky? Well, imagine you had a toaster that was sitting directly underneath your smoke detector and it was on a very high setting. Is your smoke alarm still flaky? Or is the thing that you're measuring not quite right? We need to get to the bottom of it. We need to look at the whole story and stop using the F word. Let's look at our applications. So not too long after this happened, we had another issue with inconsistent or flaky tests at my work. So we had a whole bunch of acceptance tests, and they gave us really good confidence that our app was ready to release to production. And we did that very frequently. And we'd never release our app unless all our acceptance tests had passed. We had about 500 tests, and we ran them in parallel in about 50 groups, each having about 10 tests. And it meant that the entire suite could run in as little as 10 minutes for the entire suite, which was pretty sweet. And so we wanted to get a build released, and 5 of our 50 groups failed on the first run. So what we did was we reran those 5 groups, and I think then one group just failed. So we reran that one group, and it passed. Our build was green, and we released it to production. We didn't ask why our tests had failed in the first place. So shortly after we released to production, we started seeing our customers were losing their sessions and crashing. But all our tests had passed. We had a closer look and found that we had an obscure caching bug where the display mode between desktop and mobile was being incorrectly cached and displayed for the wrong user's session. This was killing the user's session, and it was affecting our sales. It wasn't immediately obvious, as it wasn't happening for every customer. It was only happening for about 10%. 5 groups out of 50 is also 10%. Our tests had found this bug, but we'd completely ignored them. We'd ignored them until it didn't happen anymore, but our tests knew that we had an issue. Trust the tests. Don't rerun blindly until you get the response that you want. Find the issue and fix it. Kill any possibility for flakiness. We had another situation with an app that I was working on, and we were running some tests in parallel, because running tests in parallel is very efficient and replicates how our users use our systems. We encountered some flakiness or inconsistency in our test results. Our app happened to have a feature that we didn't know about, where a subsequent logon to the first would destroy the original session in some cases. So if 2 of our tests happen to run in parallel at exactly the same time, the second test would make the first one fail. Spending time trying to make our tests resilient or reliable would be fruitless. It was built into our application design. Our app should have been testable, and it shouldn't have killed the subsequent sessions. It wasn't meant to happen. So rather than going on a flakiness hunt for our flaky test, we refused to believe in it, and we discovered application quirks that were disguised as test flakiness. Our faith in testing was restored. Our tests had revealed the true story. Thank goodness it wasn't a flaky monster under our bed. We'd shone our torch, our trusty tests on it, and realized it was just some dusty bits of our application design. There was nothing to be afraid of. We had a single page internal web app that I was working on, and it used dialogues upon dialogues with pop-ups and asynchronous server calls everywhere. Our tests would dismiss a dialogue, and it would miraculously reopen when a callback was later received. It would make our tests very flaky. What we could have done was make our tests resilient as to expect a random pop-up at any moment and dismiss it. And I have seen that done. But why should we write such complicated tests? What's the real issue? Why should we have highly resilient tests for such a clunky application? Shouldn't we look at the reason behind the flake? We decided to work as a team to make our app more testable, to show spinners for AJAX calls, to make dialogues not miraculously reappear, and to provide hooks so you could know when asynchronous stuff was happening via JavaScript. We did this, and guess what? Our tests were suddenly consistently passing. Flakiness 0, application testability 1. I worked on another app, and it was to order pizza. It was a multi-step flow, and every step relied on some state from a previous step. If we were to write tests that included every step and any combination of steps, there'd be lots of possibilities for flakiness and inconsistencies. Instead, we chose to write a test-specific controller, which was embedded as part of our application, to instantly display any page in our app with any state that you required. So there was no navigating of pages and no constraints around time or data. If you can set up a single URL with everything that you need to test some functionality, this means your tests can be focused on testing and avoiding flakiness by avoiding navigation and layers of setup and options. We built testability well and truly into our app. The integration of testing into system development saved us from flakiness and complicated after-the-fact test writing. Don't be afraid to add testability-specific features to your apps that don't serve a functional purpose. I recently had to get new tires on my car, and I realized that a lot of tires have testability features. They're called tread indicators. They don't serve any functional purpose. A tire doesn't need a tread indicator to operate, but it does make it possible to quickly and easily test the tread of a tire without any complicated measurement instruments. Why don't you consider investing in similar testability features for your apps? These are two of the most annoying messages and pop-ups I see on internet sites that I use. They're particular to sites that don't cater well for browser navigation. So tests for these sites can be flaky, as it's really hard to handle these pop-ups in test automation. They also cause a lot of fear in our users. Has it taken my money? Have I double booked? how long should I look at this screen before I refresh? So there's a lot of user panic. But what if we built our apps so that didn't have these problems? Our tests wouldn't need to cater for them, and we'd have a better user experience. How? Well, we design and build your app with testability in mind. An integrated team of developers and testers throughout the whole process is ideal. A testable app is a usable app, and usable apps aren't flaky. So you might be asking, what can I do to help kill flaky? We all have a role to play in restoring faith in our profession and pushing flakiness into extinction. Number one, don't blindly rerun tests. If you roll a dice enough number of times, it'll give you the number that you want. But is that the same thing that happens if a real user rolled a dice? No, it's not realistic. We need to look at why it failed the first time, why you didn't roll a 6 straight away. There's a reason you didn't roll a 6. It's a dice after all. Maybe you need to use a different approach altogether. Number 2, use flaky tests as insights into your apps. Flaky tests are not useless. They're telling you something. You just need to work out what that something is. Be the test whisperer and decode it. You'll be rewarded with a secret about your app or an area for enhancement. And number 3, build testability into your apps. Flakiness comes from after-the-fact testing. We're not an afterthought. Testers and test engineers should be part of application design teams. We need to consider and build testing and testability into our application designs. Efficiency, effectiveness, and testing confidence comes from this strong base. I'd like to finish with a final message to flaky tests. What I do have are a very particular set of skills. Skills I have acquired over a very long testing career. Skills that make me a nightmare for flaky tests like you. I will look for you, I will find you, and I will kill you. Cheers.
Thank you, Alistair. You have a lot of questions coming your way, so it's a good thing we've got a lot of time.
Yep.
So the first one, isn't it a question of probabilities? A bug that manifests in a flaky result is less likely to be seen in production than a test that always fails. How do you convince the team members that fixing flakiness is a priority?
Let me just read it again. I guess I sort of disagree, because I have seen a lot of flaky, doing a lot of research into these flaky tests, which I've sort of demonstrated today. Like, I have actually shown that a lot of these things do actually come through in production. We just don't realize it. Like, so my example of where we had a quirk in our application where, like, multiple logins, the second one would kill the first. No one had any idea about that. It was happening in production. We just had no idea about it. Our test was flaky because of it, but it was an application issue all along, and so it was actually in production. The question's not there anymore, but yeah, that's my...
How do you convince the team members that fixing flakiness is a priority is the other part?
Sure. Well, I think a good way to do that is to actually like make the prominence or make flakiness very prominent. And so ways I've done that before is like make sure that everyone can see that we've got a flaky build. So having like things like build lights and build monitors and things like that, making it really clear that we've got like like our build is failing and it's red. We can't push that. And then people will start seeing that and say, well, why is it red? Okay, let's have a look into it. And then sort of dismissing that, hey, it's this flaky test, and then like really starting to delve into it and looking at it. And people often say, well, it's gonna cost a lot of time and money to do this, but like not doing it is also going to cost a lot of money and time and prod issues and things like that. So, yeah.
Our team finds that tests fail due to hardware, OS, network, and job management problems, often enough that it is not worth investigating flakiness below a certain threshold. Do you agree with this strategy?
Yeah, well, no. So I think that like if you so any one of those things like can cause the flakiness in our tests. So if you're finding those, we need to actually make a testability feature that we can get rid of that flakiness. So if we've got an issue with like network, we need to say, hey, how can we make our app like better so it can run on like flaky networks? Or how can we make our app better so that it can run in a test mode where it doesn't need to use the network? Or it's like, how can we actually improve our app to like mitigate any of these like potential reasons for flakiness? So like if you can, like an example, an app I worked on, we had like all these issues around flakiness around time, and then so we're like, well, how about we just like make our app so that we've got a mode where it doesn't sort of like worry about time. We can test everything else, and then we can like test time separately. And instead of time affecting like every single test that we've got, we didn't worry about time, and then we could just test time in this little thing over here. So I guess it's just worth looking at like any of these issues that people say, hey, that's the reason for flakiness, and then just trying to work out, hey, can we use testability to solve those?
The challenge with flaky tests is that they are very difficult to reproduce. Do you have suggestion for pinning these down?
Yeah, that's a very good question. So what I've found to work out what it is, because as I said, I've spent a lot of time doing this. So things like logging and screenshots and recording videos of tests running, like these are really good things. Like a lot of like CI tools do this anyway, but they're really good techniques to actually like basically, you know, be that test whisperer trying to work out exactly why it's happening. Oftentimes, like you can run it like locally in a dev environment and it passes every time, and then every time you run it in CI, but when it's like running in parallel, it'll fail. So yeah, if you can put things like turn logging on, put in like debug statements, if you can capture screenshots every time it fails, or like you have a mode that every time it runs it does a screenshot on everything it does. Like all these different things that you can do, you can use all that information to realize, hey, this is why it's flaky. And that's what we did for like the issue where we had the subsequent logons, where like we really need to actually start looking at the screenshots and the logs and trying to work out exactly why this is failing. Because every time we ran one of those tests locally, just as a single test, it would pass. There would be no way it would fail. But when we ran it in parallel, it would fail. So.
And I'm going to add one thing to that because I have the power of the microphone. I would also say production monitoring, so that you actually realize like this is a real problem in production. This isn't just a flaky test. Yes, actually 10% of users could be correlated back to this thing in production.
Exactly, yeah, because like the example I gave where 10% of our users were like completely affecting our sales, like that was production monitoring. So it's like really important.
Okay, back to questions. What about diminishing returns of test stability? How do we justify X weeks of software engineers' time fixing something that only affects tests versus stabilizing the tests themselves?
Yeah, that's a good question as well. So, Yvette, I think you talked this morning about Google Maps and spending 2 weeks on the sort of like flaky test.
Unfortunately, I did.
Yeah, so, I mean, we already spend a lot, like, we spend a huge amount of money and investment on flaky tests, right? Like, we do that already. So, by reinvesting that effort in testability, I've seen that the benefits are much more substantial. So it's not about spending more money on testability. It's just about spending less money on flakiness, spending more money on testability, like diverting that money to testability. So I've seen it, like in all the examples that I presented. Like I've seen it in a team how greatly the team is so much more confident if they can have consistent green builds and being able to release to production consistently without any flaky tests. Like it's like a priceless thing to have. So,
is it or is it not a general best practice to ship internal testability hooks as part of the shipping software package? If we do, aren't we exposing internal tools to customers that increase the size of the ship software but provide no use to the customer?
So all the testability stuff that I mentioned in my talk, we basically, through config, we disabled it in production builds. And I think we even, in staging builds, we actually disabled it as well because we wanted that to be very much like production. So if any sort of testability feature, like I talked about the pizza app, so any ability to basically like jump straight into like customizing a pizza and setting up all this different data, like there was no way that a user could access that in a production or staging environment. So we're very, and we had a lot of config tests, so we're very, everything was heavily driven by config, and we came up with a cool idea to actually have like unit tests for config. So you could actually, every time you change config, you'd actually write a unit test for it. So we had a lot of confidence, I guess, that our production config didn't include any of our testing stuff, because I don't think it's very good, like from a size point of view, and also from a like risk management point of view. It's not very good to actually like ship testability features to customers.
How do you know that you are validating real-world conditions when you test a specific controller?
Yeah, so with the test controller, like it was full stack. So it did use services, it did use the database. It just was really like, I guess, like a setup, like a quick mechanism. So it was like a basically way of setting up state in your application and redirecting to a certain point so that you could actually see that. Saying that, it is a valid question because like they weren't the only tests that we had. So I think I mentioned we had about 500 tests, and about 450 of those approximately would have used the test controller. So they're like very targeted. They would just be, the way that the test would work, it would say, hey, I call this test controller, I get to where I want, and I do some assertions. The remaining 50 are the sort of like the top of our test pyramid, and they're our end-to-end real user tests. So they basically go through from the start of like specifying who you are to order pizza, selecting your address, going through, choosing a Hawaiian pizza, doing all sorts of stuff to it, and then saying, hey, it needs to be delivered to my door, and being able to see a pizza tracker. We had like a handful of those. We limited them. There was nowhere near as many, but they didn't use any of the testability sort of features because they were representative. And the benefit of those, as I said before, our testability stuff was disabled in production, but because our end-to-end tests didn't use any of that, we could actually run those in production, which we did. So we actually ran them in dev, test, staging, and we actually ran them in production. So every time we did a production release, we'd run those. They would order 3 weeks in advance, so we could have time to cancel them. But yeah, so we could actually use those tests. So it wasn't just we weren't just using testability features. We were actually like complementing it with real end-to-end testing.
Okay. What about Heisenberg bugs? Instrumentation changes outcome and prevents reproduction. So what do you do when your actual instrumentation and your test hooks cause something to change?
I guess we didn't see that a whole amount. These, like any of these testability like hooks or changes were like completely reproducible in a development environment. So it was very easy to run our app locally in debug mode and actually use one of these like testability features and see exactly what was happening. And just running it in debug, you could actually see the values of everything. So I guess being able to do that, we could actually like iron out whether there were any issues in that. But the benefits far outweighed any like issues that we ever had with that. I've never heard of Heisenbergs, but I'll look that one up.
Was it difficult to convince people to undertake this effort?
Yeah, it was. Like particularly developers, because as I said, like with the question we had before, like it is a fair bit of effort, but it is about, I guess, changing your focus. It was hard to convince people, but as soon as we actually made some gains, and like just taking like a single bug that you have in production and then like saying, oh, how can we test this like smartly, introducing a testability feature for it, and actually doing that by doing like small examples and proving and showing how they can be effective, you soon get buy-in. And then basically, as I said before, like as soon as you have consistent builds passing, everyone thinks it's the best thing in the world because they're no longer like questioning the quality.
I'm going to throw in my own follow-up question, which is how do you measure flakiness and sort of follow that along? Because you're talking about like, you know, showing proof of concept and then iterating on that. How do you actually measure flakiness?
I guess the only way you can really measure it is by every failed build that you have, looking at it and then just asking whether it's a legitimate fail. And so firstly, like I guess reducing how many failed builds you have, and then if you are having builds that have failed, just look at them and say, hey, is this a legitimate bug? And how easily you can determine, how quickly you can determine that, hey, this is a legitimate bug that we need to fix. And then as soon as you start realizing that every build that fails is a legitimate bug, then I guess that's when you've got confidence that you have eliminated flakiness.
One last question. What helps you to inculcate? You guys are teaching me new words. Thank you. A culture of testable design within the developer community. What do you do when they want to cut corners to release urgent features?
Again, a really good question. I think it sort of goes back to what I said, that it is really like a long-term view, and it's just really like showing, like demonstrating the ability of like, well, the effectiveness of doing this, and then in small amounts, and then sort of gaining momentum over time. And like ultimately, like every developer I've worked with has actually sort of been involved in this. Ultimately, they love it because it gives them really good confidence to make changes, which every developer wants. It gives them really good confidence to do a release, and it reduces how many calls they get after hours because something's crashed. So yeah, everyone I've been involved with has actually like loved this process, but it's just a matter of like changing that culture over time. And really, the only way to like deliver like fast software sustainably is to have like very reliable, non-flaky tests.
Thank you, Alistair.
Thank you.
So with that, we're going to go to a break. Please return to this room by 4 o'clock so we can finish up our day. Refreshments, beverages outside the room.
battery just have some props.
Oh, yeah. Okay.
So I just want to show a few assistive technology devices that people might typically use.
Oh, okay.
So if it's all right, I'll just leave them up here so I don't have to fumble with them. Or
yeah,
we've got
a couple demos coming up.
Okay.
Do you want me to hold? I can hold on to
I can
them.
bring them up. I'll just drop them here and I'll take them after the end of the talk.
Is that all right?
feel it right here.
Yeah.
So, the vent is ticking right on here. So, and everybody, but that's air conditioning. It's about 6 degrees warmer back in the back of the room.
That's why I don't want to make it warm back there.
Right.
But it doesn't feel super cold to me here.
No, I mean, but stand here sit there for an hour, it gets cold.
brain is gone. There we go. Welcome back. I hope you all had a chance to warm up a little bit. We've got our last few talks of the day coming up. And we're going to kick it off with Adam Carmi talking about large-scale automated visual testing.
Thank you. Hi, everyone. I'm Adam Carmi. I'm the co-founder and VP R&D of ApplyTools. We're a company that provides a cloud service for automated visual testing. Large-scale automated visual testing is a reality today. There are teams that are running, executing thousands and tens of thousands of visual tests on a daily basis. And this talk will focus on the key tips and guidelines that are crucial to succeeding with visual testing at this scale. So for those of you who are not familiar with visual testing, I'll start with a brief introduction. I'll explain what visual testing is and why it should be automated. I'll also explain how automated visual testing tools work. And the remainder of the talk will focus on the scale-up tips, and we'll have time at the end to answer any questions that you may have. So what is visual testing? It's a quality assurance activity aimed to verify that a graphical user interface appears correctly to users. Now, this goes beyond the traditional functional testing that you used to do with tools like Selenium and Appium, where you test the functionality of the application through the UI. What we're focusing on here is making sure that the UI itself appears right and correct to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. This type of testing has become increasingly difficult to perform in recent years, mainly due to the explosions of browsers, devices, operating systems, and screen resolutions that applications are expected to run on today. So here you can see an example of a visual bug that we found in the Microsoft Azure Management Portal. You can see here how the graph exceeded the expected bounds of the page. And this is how the Amazon website looked like for several hours for some customers during Amazon Prime Day 3 months ago. So I'm sure you've all seen these type of bugs, and maybe in your own application, and you understand their severity. They can be very embarrassing and damage the brand of the company. But in some situation, they can completely cripple the functionality of the application and end up costing a lot of money, which will probably what happened in this case. So why should we automate this type of testing? There are many reasons, but the most important one is that the test matrix is just too big to cover manually. Think of all the different web browsers, devices, operating systems, and screen resolutions that your application is expected to run on. We all know that a website that looks good on Chrome doesn't imply that it looks good on IE, and an application that looks good on a widescreen doesn't mean that it would look good on a smartphone. So we have to test our application in all these different environments, which can be very ineffective and costly to do manually. If your application is responsive, and most modern applications are, then you also need to test all the different layout modes in all these different environments. If it's localized, then you also need to factor in the fonts, resources, images, and content that is specific to each language. And of course, even if you don't change a line of code in your application, still you depend on third-party upgrades that can introduce visual bugs to your application. An example for that is a web browser that updates every few weeks, and whenever it does, it can introduce incompatibilities with your website that may be manifest as visual bugs. So you have to test a lot of things many times, and it's just too ineffective to do manually. What makes things even worse is the fact that release cycles keep getting shorter and shorter. So companies that are doing continuous deployment today, which is the current hype, are releasing to production several times a day. And with such short release cycles, there's hardly any time to do any type of manual testing, let alone making sure that your application looks good in so many execution environments. So let's take a look at how these tools actually work. So there are many automated visual testing tools out there, and they all share the same workflow with these 4 simple steps. In the first step, you drive the application on the test and take screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. These images define the expected appearance of the application. And in the majority of cases, these are simply screenshots that were taken in the past and approved by a human tester. In the third step, the tool generates a report following the test run that includes all the screenshots, all the baseline images, and any differences that were found during the test. And in the fourth step, tester has to look at the report if any changes were found and decide for each change if it's a bug, in which case he opens a bug, or if it's a valid change to the application, he simply approves the new screenshot to be used as a baseline images for subsequent runs. Here you can see an example of the first two steps, taking screenshots and updating them, with an open source visual test automation tool called WebDriver CSS. As you can see, JavaScript based, and it extends the WebDriver IO WebDriver. And this test is very simple. You can see that it starts with the instance of the WebDriver IO. It initializes it, which causes the browser to open. In this case, it would be a local Chrome browser. Then it navigates to the example.com URL. And then it performs a visual validation point with the WebDriver CSS command, which takes 3 parameters. The first is a name for the checkpoint. That's how it will appear in the report. And then a list of elements that you want to validate. In this case, there are 2 elements, header and hero, and they are both defined with CSS locators. And the third parameter that is a callback that is called if differences are found. There you can assert and make sure that the differences do not exceed any mismatch tolerance that is predefined. So you can see here how easy it is to take an existing functional test, in this case a WebDriver test, and just turn it into an automated visual test with a few lines of code. Here you can see an example of the 2 last steps, viewing the report and updating it with a tool called Gemini, also an open source tool. You can see here that you have a list of all the checkpoints. The one that has differences are marked in red. And you can see for each difference that is found that you have an image of the baseline. It's called reference in this tool, the screenshots that have been validated, and also a diff image, which is basically the screenshot with all the different pixels highlighted in pink, so it would be easy to identify the change. And the maintenance operation that you need to do if you decide that this is not a bug is just click this button over here, the arrow, and this would replace and set the screenshot as the baseline for subsequent runs. There are many visual test automation tools available, so if you want to get started with them, you have a lot of options to choose from. It is important to highlight that the majority of tools, all of them almost only work for websites. They won't work for mobile applications. The only 2 exceptions are Facebook Snapshot Test Case by Facebook that can test iOS applications, and Applitools Eyes that will work for any mobile application that can be driven with Appium. And that concludes our brief introduction to visual testing. Let's proceed with the scale-up tips. And the first tip is naturally use a robust image comparison engine. And if you'll allow me to quote Boromir, then one does not simply do bitmap comparison. And the reason you don't do it is that if you do it, is you get a lot of false positives. False positives in the context of visual testing is a case where the tool tells you that there's a difference, but you as a human being cannot see it, or it's so minute that you don't care about it. And there are many, many reasons for these false positives if you're just doing simple pixel-to-pixel comparison. And let's take a look at some of the most common ones. So the first one has to do with an image processing effect called anti-aliasing. And here's an example of it. You can see we have at the bottom of the image a navigation bar, and the playlist tab is magnified. You can see at the bottom that the playlist text appears in white. And probably that's what the color of the text was in the DOM or whatever. But you can see in the magnified image that actually many of the pixels are not white. They have different shades of blue. This is anti-aliasing at work. Okay, basically, the rendering engine, which is the graphics card or whatever is responsible for rendering this image, is painting certain pixel along the border of the lines in different shades and intensities and colors, and in order to make the text appear smoother to us. The problem with anti-aliasing is that if you run your test on several machines, which makes sense if you have more than one tester in your team, or if you're running your test in a lab, which makes sense if you are trying to scale up, is that you'll get different rendering engines painting those pixels, which means different implementations of the anti-aliasing algorithm. So this, for instance, is how anti-aliasing will look like on a different machine. I will toggle between the two, and you can see how different the pixels are. Not that different. How different they are in position and color. Then again, you need a very sophisticated image comparison engine in order to be able to identify that these different pixels are actually invisible to the human eye and just ignore them, otherwise your test will fail. A similar case has to do with pixel brightness when run on different machines, or even on the same machine, which is connected to a monitor with different capabilities. You can see how different the intensity of the pixels can be. This example has to do with the positioning of text. So this is, you probably recognize it, is the Dropbox website, and you can see that the upgrade account element is moving. The reason that it's moving is that to the right of it, there is a username, and whenever we run the test, there's a different username. It has different length, and because of that, the upgrade account element is moving. So we would still want to visually validate it. So one simple solution to this problem would be to just capture a screenshot of the upgrade account element and compare it to a baseline that just for that element. And so it doesn't really matter where it appears on the page. That's a very good idea, but if you're doing pixel-to-pixel comparison, it will still not work, because although it seems that the upgrade account element moves as a whole, actually each individual letter is positioned on its own. So you can see how the A and C and O letters are positioned in different pixels. And then again, you need the image comparison engine to be able to realize that all these different pixels are actually look the same to a human. The last example I'll show you has to do with Gmail scaling, which happens all the time in every application. What you see here is this car here and the small magnified box here. And what happens is that whenever you have an image element in your application and the source image that it's showing is not exactly of the same size, the rendering engine will actually scale it so it would fit the target position. And then again, two different rendering engines would use a different scaling algorithm, and that would actually result with extremely different pixels, as you can see here. So again, extremely different pixels, but completely invisible to us as humans. And again, this is something that the tool needs to be able to take care of. And there's more. There could be arbitrary pixel offsets. Some could be small, like text or paragraph displayed at 1 pixel offset. Some could be more severe, like a column of a table being 1 pixel wider. And that would move the entire page 1 pixel to the side, resulting with a 70% pixel-wide change of the image, but still completely invisible to us. You need to be able to deal with dynamic content, such as dates and ads and usernames, moving elements like the upgrade account samples as we saw before, comparing images of different sizes. And of course, the image comparison engine has to be extremely fast, otherwise your test will take forever to run. And there are those that always get mismatches, and there's nothing you can do about it. But seriously, visual test automation tools have come very, very long way they can very successfully handle this type of false positives today. But before you start working with a visual test automation tool, you need to make sure that it works very stable for your app, because if you won't be able to get away from these false positives, there is no way that you'll be able to scale up your tests. Tip number 2, use a single baseline across devices and browsers. So the idea here is to reduce the amount of maintenance that you have to do, especially with regards to cross-browser and cross-device testing, by reducing the amount of baseline images that you need to maintain. And this is how you do it. You keep a set of baseline images for your application on for a specific execution environment. Let's say Chrome on Windows. And whenever you have a new release of your application, you use that same baseline to validate that new release on exactly the same environment. Basically, you're doing visual regression testing. You can find unexpected changes. You can use a very strict matching algorithm to do that, because your application is running on the same execution environment, and so it should render exactly the same. Once you're done with that process and you have updated your baseline to reflect the new version, you can then use the same set of baseline images to make sure that your application renders correctly in other execution environments, such as other browsers, other devices, or form factors, by making sure that their layout or structure is consistent with that of the baseline. And I'll show you an example of this to clarify it using Amplitude's eyes. OK, so the first example is for a cross-browser test. You can see the baseline image here on the left-hand side and the screenshot that we're validating on the right-hand side. You can see that the baseline image was taken on Chrome, and the screenshot was taken on IE. If we toggle between the two images, you can see how different the browser renders these images. You can see that the fonts are slightly smaller or bigger. They change position. The text here wraps a bit differently. But when we're performing a structural comparison, all of this is fine. The images are consistent in terms of layout and structure. We have this radar button here that we can click to find any differences that we did find. And we can see that we have a difference at the bottom. If we zoom into it, we discover that we actually did have a missing element in IE. So this is an example of how you can use structural matching to find bugs between across the browsers. The next example shows a cross-device test. This is Twitter on 2 different mobile devices. And we have 2 violations here. So the first one it occurs here. The baseline image dictates that the paragraph should be aligned to the right of the image. And this is broken here. Here at the bottom, we have an image, but it is missing in the screenshot. So again, all these structural changes can be caught. And if you see, when I toggle the screenshots, the 2 tweets in the middle, although they have different images and text in them, are not highlighted as different because structurally they are equivalent. Another very powerful application of structural or layout matching is monitoring and testing dynamic applications. So in this case, we have the Yahoo website, and the screenshot and the baseline were taken in a 24-hour difference. You can see how different the images are and the articles, but still, structurally, they are equivalent and no difference is reported. If I would change this to a more strict match, you can see that all the dynamic parts are highlighted and the fixed ones aren't. But if I would do pixel-to-pixel comparison on this page, you can see that actually everything is highlighted. And the reason is that everything here is different, only we cannot see it. And strict matching in this case is powerful enough to ignore all of that. Back to the slides. OK, tip number 3, baseline maintenance should be codeless. In the majority of cases, maintaining the baseline involves looking at the screenshot and clicking a button to approve it as a baseline. In some rare situations, you also need to mark 1 or more regions on that baseline that are dynamic, and you don't want them to be matched during image comparison. So actually, there is no real value or benefit to doing this kind of maintenance in code. On the other hand, if you do it in a codeless way, there is a huge advantage. First, everyone in your team can do it, even those members of your team that don't know how to code. More importantly, they can do it immediately when they see the change. So just think about the huge difference if you have hundreds of baseline images to maintain. And when you see a difference, instead of just clicking a button and accepting it, you need to open up an IDE, find the test code related, change the code there, and making sure you don't introduce new bugs, or even worse, find the guy responsible for the test, open a ticket for him to fix the test. It could be a difference of hours and hours of work for every test run. There's another mini tip here that is a bit counterintuitive, and it is to prefer full page validation over element-specific validation. The reason this is preferable is because it's allows you to avoid maintaining those element locators in code that tend to break when the UI changes. Tip number 4, maintain at the test suite level rather than at the test level. Now, this seems a bit trivial, but actually it's a very important tip. There are situations with visual testing where there is one bug or one change in the system or very few changes that are captured by multiple checkpoints across many of your tests. Just think how frustrating it would be if you would have a build that fails and the report would show you 200 tests that have failed, and now you have to go over one by one, choosing the first test, looking at the difference, resolving them, going back to the list, looking at the next test, and so on and so forth. What is much preferable is just to see all the changes that happened during that build and immediately have the ability to resolve them and completely ignore the tests. In fact, what you would really want to have is the ability to see only the unique changes and not all of their occurrences. And this leads us to the final tip, which is automate your maintenance. And in order to explain to you what automated maintenance means, I'll show you another demo with Amplitude's eyes. Another demo. Great. So for the purpose of this demo, I prepared a small test suite for the GTAC website. And I ran it. I created a baseline. I simulated the difference. And then I ran it again. And let's see the results. So in this case, we see that the test suites, or batch as we call it, is called GTAC. It ran, and it appears as red, meaning that it found differences. A small summary here tells us that there were 28 tests there. They covered 3 environments. Those would be IE, Firefox, and Chrome on a Windows machine. 3 form factors that correspond to the 3 layout modes that the website supports. It's a responsive website. And in total, we had 91 checkpoints that all of them found differences. So let's look at the first image, click the radar and see, and we can see that we have a small difference here at the footer. Let's zoom in and see what we found. We toggle between the images, and we see that we have a plus symbol that changed to a minus. So let's assume for the let's assume for the sake of the demo that this is not a bug, but actually it's a rebranding of the product, and so we want to approve it. But before we do, let's look at the other images. So we look at this one, and oh, it's the same place. It's probably the same change, right? And this one, oops, let me go back here. And this one, probably the same. And this here, this one at the bottom, again, the same. So, but it makes sense, right? We just changed the name of the product. It probably appears in all the images. So we are really tempted to click this button that says accept all. I'm not going to do that. I'm going to click on another button. And I'll explain why I'm not clicking that button. Accept all basically means override the baseline with all the screenshots that I found. And all the visual test automation tools allow you to do that. But actually, it's a very dangerous thing to do, because what you're actually doing is skipping maintenance. So you could introduce bugs, real bugs, into your baseline and then prevent the tool from finding them later on. So if I was free to choose a name for this button, it would be skip maintenance, and the tooltip would be I'm too lazy to do my job. Basically, what I just did is I asked the tool to do this maintenance operation for me in an automated way. I asked it to find all the similar differences. And the result is that from this build that had all these failures, I only have 2 images to look at right now. 90 of the checkpoints have exactly the same change. Although they ran on different browsers and they ran in different layout modes and form factors, still a plus changed to a minus, and that's it. So I can just go ahead and approve that because that's what I want to do. I have another change here, and let's see what we found here. And although it's subjective, I think that you can agree with me that we found a bug. And so we won't accept it, but reject it. And with that, we're done maintaining our test run. So there are many opportunities with visual testing to do this type of automatic maintenance. As you can realize, it goes a very long way in allowing you to scale up your test without introducing more overhead to your maintenance. And with this, I conclude my talk, and I hope that you learned something new and enjoyed it. And I'll be happy to take your questions now.
Well, thank you, Adam. You have earned your free lunch by finding bugs on our website.
Yeah.
So for the first question, how does your baseline strategy work in a continuous build and release model?
So basically, it would work like it has nothing to do with a continuous release or build model. So basically, you run the test, there are failures, you look at them. If there's a failure, you don't release immediately. You wait until someone approves it. So it's basically, it fits right in there. And it's actually the safe way to do continuous deployment, because instead of just releasing stuff without looking at it, you know when there's a change.
How do you minimize the cost of writing and maintaining a new set of tests?
So there are different strategies that different teams use to do visual testing. Some would write new tests, very simple tests that just browse through the application. If it's a website, usually they'll just put in a set of URLs of a few lines of code, and it will just go over the entire set of pages on all the different execution environments, and you're done. Other teams will take their existing tests and just add validation points where they want to. And others will go to their test infrastructure. Usually you have some kind of abstraction around the test driver, and you would just hook it into some operations that would automatically trigger validation points. So one of the best practices is to do a validation point immediately after you change to a different URL. And the other one is just before you click a button or a link. So that covers like 80% of everything you need, and it's just centralized at one place, and you're done, and you have full coverage for whatever test you already have running.
So how would you use the tool to test a website or mobile app that has not yet launched? Can it be run locally?
So basically, if you're asking, if the question is specific for Apply tools or for any other tools, so what's interesting? OK, so basically, the open source tools, all of them, they run locally, so there's no problem using them locally. With Apply tools specific, then we support on-premise deployments and also private cloud and public cloud deployments. But anyway, the test always runs behind the firewall, so there is no need to open up tunnels from the outside into your organization. We use, for instance, with Selenium, the WebDriver to get the screenshot, and we send them outside. So if you can Google out of your test machine, the machine that is running your test, then you can work with the service. You don't need, it can be behind the firewall.
Changing order. What's your diff engine? Is it public?
The diff engine is something that we've been working on for more than 3 years today. It's not public. That's our secret. We don't patent it as well, so we don't need to expose it. It's not open source, and there is nothing out there that we build on. It's completely from scratch to handle this type of work.
Do you use these tools as acceptance tests rather than as tests to find bugs?
Using this tool as an acceptance test is a very, very effective way to work with the tool. By the way, if you don't want to bother yourself with each build and update the changes, although this becomes an amazing collaboration tool in the team, because immediately you see everything that changed, not bugs. Even if your PM doesn't like the color of the button that the developer just changed a minute ago or 10 minutes ago, we can immediately give him this feedback. But if you don't want to do that, then you can just use it as an acceptance test, run it once before you listen to production, or use your staging environment as a dynamic baseline to match your new candidate to test it, make sure there are unexpected changes. That would be a great way to do it. So for acceptance testing, that's great. What was the other one? I forgot. Where is it?
I don't know that there was more to that question.
No, I think there was, but I feel there was, but I don't remember. Okay.
Sorry, we just.
No. Okay. No problem.
What about false positives? For example, things are expected to be different visually across runs or browsers or platforms.
Then you can just have a different baseline for each of them. So that's fine, no problem.
Cool. And we are out of time, so thank you, Adam.
You're welcome. Thank you.
So next we have Puneet talking about testing integration between Twitter services when he is ready. Master deck.
All right, so October 8th last year, Twitter sign-up was broken for almost 2 days. Stock was down 5%. How many people remember that? Yeah, so for the folks who raised their hands, that actually never happened. And this is the reason why it didn't happen. Sorry. All right, so I originally came from platform engineering and then started realizing that we had bigger problems to solve and ended up spinning up a new team called Frameworks. And one of the first things we built was this tool. And the problem we were trying to solve with this tool was that you just refactored your code. We were in the process of migrating over from a huge monolithic Ruby app to microservices-oriented architecture. So lots of opportunities to break things. And at the end of a refactor, how do you know that you haven't broken something? If you're an SRE, a site reliability engineer, and you're in DevOps, then you have an even bigger problem because you have no understanding of the code that is about to be deployed, and yet you are in the position to make the call as to whether or not a build is good enough to put out into production. And you try to mitigate that risk by canarying and doing all sorts of fun things, but eventually you want to get to continuous deploy, and that ends up being a hard problem. So our natural first line of defense comes out to be unit tests and component tests. And I personally have to make a confession. What better audience than this one to make this confession that I hate writing tests. And the reason is the following: that if you look at unit tests, it can often take you more time to write good unit tests than writing the code that's being tested. Let's say your method has 5 possible code paths, and you're interested in 100% path coverage. Then one test will get you 20% coverage. You write 5 tests, and you're done. Great. I mean, I can write 5 tests. That's not a problem. But 5 tests for every method. Then you get a bit more ambitious and you say that I want component test coverage. And in this example, I have 5 methods in my service. So my component is a microservice, and the request path has 5 methods in it. And each method has 5 independent code paths. So this works out to about 15,000 independent code paths. Now, who here has written 15,000 tests for anything? Right. Wow. I have a lot of respect for you, sir.
But our team has billions of test cases.
Right. OK. Well, kudos to you guys. But the thing to be cognizant of here is that as the complexity of the system that you're trying to test grows, the relative impact of every handwritten test is smaller and smaller. And if I take the example of one of our services in production, and I use the production cluster that's running that service just to run tests, it would take about 1,000 years for that cluster to finish running all the tests covering every single possible code paths. Meanwhile, the life cycle of that software is barely a week, because that's how long it'll be before the next version of the code will get deployed. So we need to be cognizant of the impact that we can make as complexity grows. And if you don't trust me, hopefully you trust this guy. So what's our approach to automatically trying to find regressions and figuring out whether we've broken something? Well, first we start by saying, if you look at a test, it's finding a way to trigger a behavior, right, which is providing a test input. And what better way to trigger the behavior that you're interested in than to use production traffic for microservices? So we started using production traffic to drive the behavior of undeployed code. And that basically made sure that we were exercising the code paths that were going to be eventually exercised in production. We preferred this approach to randomized testing or other kinds of testing because with those approaches, while you might get different kinds of coverage and whatnot, there are a lot of data-driven things in your code which only happen to surface when you get the right sequence of characters and whatnot that are easy to find in production traffic than randomly generated strings and things like that. So using production traffic to drive the behavior of undeployed code turned out to be a good approach. And then the second part is once you've had your interaction with the undeployed code, then you want to assert that the behavior was correct. So how do you do that? And you make the assumption that the stuff that's currently deployed in production isn't broken. Sometimes there can be the wrong assumptions, but most of the times, if production's on fire, you find out pretty soon. And if it's not, then you can assume that the stuff in production is good. But there is a problem. You're using the same request. You're sending it to the new code and to the old code. And then you're comparing the responses that are coming back from these two deployments. And in this response, you might have a lot of fields, deeply nested fields. And some of these fields might be inherently noisy. So how do you deal with them, right? Your noise could be, for example, from server-generated timestamps, because the clock is never going to be exactly the same across two different machines. And it's not the software's fault. It's just a different clock. You could have random number generators, and you may not have set the seed, in which case, again, you have another source of non-determinism. You might have live data for downstream services that you're using for both the environments. And if that downstream data is changing rapidly, then that can be yet another source of non-determinism, because you can have a write in between the two reads that the two live and undeployed versions do. So here's the big idea with Diffie, where once you have production traffic that you're driving through the Diffie proxy, it will multicast this traffic to not just to the old code and to the new code, but two versions of the old code. So in this diagram, you see a candidate at the top. This is the new code, right? The code that needs testing. The primary and secondary are two deployments of the exact same known good code, which also happens to be currently deployed in production, right? So all of these three instances are running in my isolated staging environment. Then, when the traffic hits these instances, and we get the responses back, we do a comparison between the candidate and primary. So that's a comparison between the new code and the old code, which gives us a raw set of differences, right? And then this raw set of differences has a lot of noise in it, right? And then by comparing the old code to itself, which is the comparison that's happening here between primary and secondary, we isolate all the fields that are inherently noisy. So anything that shows up as noise here between primary and secondary gets subtracted out from the raw differences, and you get a final filtered set of differences that allows you to focus in on things that you should be looking at, as opposed to trying to find a needle in a haystack. And with that, let me switch over to the demo. So As I showed you in that diagram, we need 3 instances. So the first one up here, running on port 9000, is my primary. The second one here, running on port 9100, is my secondary. And then my candidate is running on this port 9200, right? So let me look at my Diffie configuration. So candidate is running at 9200, great. Primary 9000, and secondary 9100, great. So let's run this. Okay, so I have my Diffie instance deployed now, and it's not doing anything interesting. So let's send some traffic to it. And since I don't have a production traffic source, I'm just going to run a bunch of curl commands that I have in this script here. OK, so we just sent a whole bunch of traffic to this Diffie instance. It showed up in the logs here. And you can also see that traffic being multicast to all of these service instances. So let's go back to the Diffie instance. Wow, 100% of the traffic failing, and it tells me that this endpoint's called JSON. So let's go take a look at what these differences look like. OK, dates coming out to be different, 49 seconds, 50 seconds. OK, what else is different? Names are coming out to be different. Interesting. And then timestamps are coming out to be different. So notice that it says 100% failing, 100% noise. So the 100% failing here is saying that 100% of the time, primary and candidate disagree with each other. And the 100% noise means that 100% of the time, primary and secondary disagree with each other. Now, in this sort of situation where 100% of the time, primary is disagreeing with secondary, you can be fairly confident that it's not your code's fault, right? Whereas up here in the name field, 12% of the time, primary is disagreeing with candidate, but primary and secondary are always agreeing with each other. So in this situation, you can be fairly confident that it is your code's fault, right? So using this primitive logic and some primitive statistical analysis, you can apply this auto-exclusion logic, and it automatically eliminates these other fields where the noise threshold is fairly high. And if we deep dive into one of these guys, we see that the words here in the responses, the names in the name field in the responses are capitalized here, whereas it's lowercase here. And it's capitalized here and it's lowercase here. So that's sort of a regression in my service, and I can deep dive into the response by blowing this up, and it gives me the full-blown request that was used to trigger this behavior, so I can reproduce it if I want. And it highlights these nice fields for me and tells me what's exactly different across the two. And the sort of diffing that's happening here is that it's recursively parsing the response data structure. In this case, it happens to be JSON, but we can also parse thrift responses and HTML. And do this sort of analysis at, throughout the structure of the response. That's my demo. So at this point, we can switch over to the master deck again. Right, any questions?
Can you hit top, please? Don't know why it doesn't always stay there. How can you handle situations where production traffic contains private user data? How can you debug?
How do you handle situations where production traffic contains private user data? How can you debug? When production traffic contains private user data, for read requests, we're just able to use production backends. And the way we're sourcing traffic is by instrumenting our production cluster. And so the reads are fine, as long as they're backed with production backends. Writes are a bit more complicated, and that's work in progress. I can talk a little bit about it. So what we're doing there is not only are we recording the requests in production, but also all the interactions with the environment for that request. And so as a result of that, what you end up doing is in your test environment, you're able to replicate or dynamically mock the behavior of the environment as it was recorded in production. So that allows you to decouple the component that's being tested completely from the environment, and you can do this sort of testing in complete isolation without having any downstream dependencies.
How do you tell Diffie to ignore expected changes such as bug fixes?
Good question. We don't, and very deliberately so. The reason is that we experimented with that earlier on, and we found that giving people the ability to write exclusion logic that you can ignore these fields creates a blind spot, because those exclusions have a life cycle of their own. And it creates a burden of maintenance on the service owners that they have to actively maintain that list, so that in the next release they don't forget to retire the exclusions that went out in the previous release. And so the way our automatic artifact promotion process is being built is that if we don't find any regressions, we automatically promote the artifact. But if we find any regressions, we require a human to sign off on those regressions and say that, yes, these changes are fine to go into production. But from Diffie's point of view, we don't give them the responsibility to maintain a list of exclusions or anything like that.
Cool. We have time for one more. How do you mock the data backend such that the undeployed code doesn't affect it adversely while still maintaining the similarity between responses?
How do you mock the data backend such that an undeployed code doesn't affect it adversely while still maintaining similarity between responses? I'm not sure if I fully understand the question.
Basically, if you've got a backend that is part of the system under test, and your front end is taking requests, and if you're only really trying to test that front end and you don't care about some dependency that's giving you like weather information that's also applied to the tweet,
right?
How do you make it so that that isn't actually what Diffie's finding?
Right. So just for clarity, in terms of the scope of Diffie does not take ownership of deploying your downstream dependencies, and that story is left up to the user. But what we do in production, or what a lot of services do at Twitter, is that we write our custom backends or like mocks for backends for these particular reasons. So, for example, if you want to replay writes, one of the things that we're able to do, or some services are able to do, is create a mock backend which just returns the OK200 response, but actually throws the downstream write away, right? So it's not actually persisting the write, and it's not trying to propagate that change further downstream. It isolates it, and that allows you to, again, keep your component decoupled from your downstream dependencies. Happy to chat more about it afterwards.
Thank you. And last up today, we have Casey Burkhart, who is going to talk about automated accessibility testing for Android applications.
Thank you. Good afternoon, everyone. My name is Casey Burkhart. I'm a member of Google's accessibility engineering team in Mountain View, California. I'm here today to talk about accessibility in terms of mobile apps, and specifically how you can leverage some new tools to automate accessibility testing to a degree within your own Android apps. Let's see what we have on the agenda today. First, we're going to cover, in general, what's accessibility? How does it manifest itself on Android? We're going to review the top developer mistakes that we see, both at Google and in third-party apps. We're going to introduce a few tools and integrations of our tools to identify accessibility issues automatically. We're going to discuss how that tool works, and specifically what it will work for, what it will not work for. And finally, we'll introduce how you can leverage these tools in your applications and in your tests to spot accessibility issues early and easily. So, first of all, what is accessibility? Accessibility really, the core of it is helping users with disabilities access your products and services, making sure it's very easy and straightforward for these users to use your apps. I like to phrase it a little differently than that, though. I like to say it's about challenging the assumptions we make as developers about our users. Okay, so some examples of this. When we're writing our apps, I'm sure everyone in this room who's written a mobile app before, or written a website or any sort of application, has said, I can assume that the user can read the screen. Accessibility is about challenging that assumption. But there's a number of other assumptions we want to challenge as well. Can we assume that the user is able to actually interact with a touchscreen? Can we assume that the user is able to differentiate color? Can we assume that the user is able to hear sound that my app is producing? So accessibility is about taking all these assumptions and building software that doesn't make them. Basically, it's a component of universal design. Accessibility also affects, when we talk about accessibility, we often hear the phrase the long tail. But actually, we're talking about a substantial number of users. 1 in 5 users in their lifetime will self-identify as having a disability. So we're talking about a substantial number of people. We're not talking about sort of fringe users or the long tail necessarily. We're talking about a substantial slice of the population here. The other thing I'd like to mention is at one time or another, we all have a disability. We have a functional disability. So for example, if you're driving your car, you can't be looking at your mobile device. You shouldn't be looking at your mobile device. If you're cooking and you have greasy hands, you may not necessarily be able to interact with the touchscreen on your device without getting it dirty. So at one point or another, we all have some sort of functional disability. Finally, accessibility and testability are very closely related. Essentially, this is a technical artifact. Most UI automation frameworks that modern-day platforms expose, actually under the hood, are implemented by using the accessibility APIs on the platform. So your UI tests are pretty much linked. They have the same behavior and the same code path executes when you action something in a UI test as will be executed by an accessibility service or assistive technology on a given platform. We had an example this morning where we were talking about offline maps in Google Maps for mobile, and about 2 weeks spent debugging an issue which came down to a developer's assumption, the assumption that the user could touch the physical display, whereas the testing tool, which most likely used the accessibility APIs, could not. It's possible, actually, it's probable that this is also was an accessibility issue in this product. For a user who's unable to touch the screen and is using another device as an input mechanism, we could very easily see how they could run into the same situation. And that assumption came back and actually produced a bug in the product. So that's an overview of accessibility. Let's briefly go over how this manifests itself on Android. So what we see here are 3 accessibility services. An accessibility service on the Android platform is sort of a long-running service that's meant to be present whenever the device is being used or interacted with, basically for the duration that a device is on. And accessibility services pretty much change the interaction model on the device. So they allow the user to access content on the device in a way that works for them. And it also allows the user to interact with that content or action controls on the device in a way that they're able. So the 3 examples I have here are the 3 accessibility services that Google ships. The first is TalkBack. It's a screen reader for Android that basically changes the interaction model to support a series of gestures. Users navigate using these gestures and move focus on the display and hear the content that gains focus spoken to them through the device's text-to-speech engine. Brailleback is another service. It works in a similar way, uses the same APIs as TalkBack, but instead of producing speech through the text-to-speech engine, it will output device content on a device like this one. This is a refreshable Braille display. It connects to Android phones and tablets over Bluetooth, and it allows the user to essentially read dynamic Braille off this row of Braille cells. And is better in situations where privacy is important. You don't necessarily want the device content spoken out loud to the world. Finally, our third service is switch access. It's intended to help users with mobility impairments access content on their device by allowing them to interact with the device in a different way. A lot of users with mobility impairments won't have the typical touch precision that we have when we interact with a touch screen. So they'll use another device, like an adaptive switch. This is an example of one, which basically provides a different input mechanism. With this switch and switch access enabled on an Android device, you can essentially control the entire device just through these two switches. In addition to accessibility services, the platform exposes a couple core accessibility features too. There are affordances on the platform for manipulating the size of text, as well as supporting magnification of the entire display. There's a mechanism to invert colors, so people who are light sensitive, like myself, can view apps in a more comfortable manner. There's affordances for changing the appearance of text with the aim to increase contrast. There's also support for captioning, so across the platform, video views and other apps that present video content have a way of discovering the user's captioning preferences. And there's also features that basically allow for color correction. So users who are colorblind and unable to distinguish two colors can essentially shift the display's color space into areas that they're more easily able to distinguish. So we've covered a lot of accessibility features that the platform offers, a lot of accessibility services that are available. And it's important to think of accessibility not only in terms of one of these services, but all of these services, and even combinations of the services at the same time. I still hear people come up to me and they go, oh, I tested my app with the screen reader, worked great, all the announcements came through at the exact time I would expect, so I'm done with accessibility. Surprise, you're not. You should be looking at all of these services and make sure that your app is exposing its content semantically in a way that works well with each of these features. So, some common developer mistakes that we see. Probably the most common is mislabeled or unlabeled content. So for example, if you use an image view somewhere in your Android application and that has some meaning to the user, you need to provide a content description to allow a screen reader or a Braille user to understand what that image represents. Equally important is making sure that your description is reasonable and you're using the right attributes to expose that information. We want to ensure that we have large enough touch targets. So users, for example, without fine motor control may not be able to hit smaller touch targets on the display. So we recommend that all your touch targets are at least 48 by 48 dips. Ensure that you have proper foreground to background contrast. Essentially what you're looking for here is a contrast ratio of 4.5 to 1 between the background and foreground color that your apps use. If you're not sure how to compute that, there's tons of online tools available to help you. And finally, you want to make sure that your view is exposing the right semantics. If your view is clickable, advertise it as clickable. Make sure you're using the affordances in the platform for handling clicks. If it's not clickable, make sure it's not reported as clickable. This, for example, can prevent users from efficiently navigating your app with switch access. So these are a few examples of common developer mistakes. But how can we find them? How do we discover them? And I think the best answer to this is through manual testing. Manual QA involves a human going through your app with assistive technology enabled and assessing the user experience for correctness. This, in my opinion, is the only way you can completely get a perspective for how users with disabilities are going to be interacting with your app. But manual testing is a costly and time-consuming process. So our team set out to think about ways in which we can improve this and speed up manual testing, reduce the number of developer cycles and back and forth that have to occur with QA organizations. So we want to find accessibility issues really early on. And we can do that for a lot of the common issues that we run into. In that vein, we created what we're calling the Android Accessibility Test Framework. It's essentially a Java library that's written and includes logic to detect a number of accessibility issues using Android UI constructs. So we can look at the views presented within your application, or we can look at another representation of them called accessibility node info. Anyone who's used UI automation on Android is probably familiar with that. And we basically have implemented this one core library that contains all of the testing logic. We made it very simple to add additional checks. So if you'd like to contribute or give us ideas on how to expand this library to find more accessibility issues, feel free to contribute a patch or get in touch with us. And we've also made it really easy to integrate this, this framework into other testing frameworks, which is our current approach. So what we've done is basically taken our accessibility test framework and included it inside Espresso and Roboelectric as an optional component. So you can get accessibility test coverage that relies on the coverage of your existing tests. So let's see what that actually looks like. So for Espresso, you would enable this feature by first of all getting the dependency from the Espresso contrib directory, and somewhere in your test lifecycle call accessibility checks.enable. For the lifetime of that test, we will run our accessibility evaluations on any view that you interact with through an Espresso view action. So we'll look, if you click a button with a view action, we'll look at that button and that button, potentially the UI around it, for accessibility issues. If your touch target is too small, if you're missing a screen reader description, we'll actually go and fail your existing test. So with very little work, you can take advantage of this integration in Espresso. And also of note, you can customize the behavior if you'd like and potentially exclude known bugs with a class known as Accessibility Validator. Here's what an example failure looks like. In this case, this is the actual Espresso output. It identifies that there's an accessibility error, gives you the view ID and Espresso's typical view representation, and notes the actual particular error. In this case, there's a speakable description missing for a screen reader. We've taken a similar approach in Roboelectric. The setup is slightly different. Instead of calling a static method, you simply annotate your test methods or your relevant test classes with the accessibility checks annotation. That will automatically enable accessibility evaluations. And any view you interact with Roboelectric's shadow view.clickonAll will receive an accessibility evaluation. It's important that you don't call view.performClick directly or invoke click listener logic, because that will potentially bypass our integration with Roboelectric. We've got more tools for suppressing known issues and other advanced functionality coming soon. In fact, I think our pull request for some new things in Roboelectric just landed this morning, so please check that out. And here's what an example of Roboelectric failure actually looks like. Again, you see the message, the view has accessibility issues and we're missing speakable text for a screen reader. And you get the actual stack trace, so you'll see the call to click on that resulted in our evaluation failing. So what can't we do? So first of all, our coverage is only as good as your coverage. If your tests don't cover your application's UI in a complete way, you may not get accessibility evaluation coverage for that UI either. So we rely on your existing tests to decide how we work and what we do. Secondly, we err on the side of caution. If we're not sure it's an accessibility issue, but it could be, we emit a warning either to the test output or logcat, depending on what platform, what integration you're using. So please check the logcat or the test output for additional potential accessibility warnings as well. And finally, we are not a replacement for manual accessibility testing. We still very highly advocate the use of manual qualitative QA to go through your app with accessibility services and understand the experience. The example I like to use here to illustrate this is we can tell if a particular control has a description for a screen reader or not, but we can't tell if that description makes sense to the user. So it's always good to have manual QA go and review these, your implementations, but you can use the automated test framework as a mechanism to speed up that step. So what's next for you? Go and try this out. If you have Espresso or Roboelectric tests, use the accessibility checks class or annotation to turn this feature on and see what you get. You probably should expect a large number of issues. We find that most apps that turn all the checks on at once run into issues that they then have to go through and suppress. But that's a good thing. You're finding a lot of issues in your apps, and you're improving the accessibility overall of the ecosystem, which we really appreciate. if you have any questions about the project, something doesn't seem to be working as you'd expect, please reach out to us on GitHub, file an issue on our GitHub page. If you have ideas for new accessibility tests we can add to our suite, please also let us know. And also, part of the reason we're here is to find what's next and learn about the next platform we want to integrate with. So if you have thoughts or recommendations or suggestions for any of that, please reach out to us as well. Thank you.
Thank you, Casey. Take a question. Have you considered including accessibility evaluation as part of the Google Play upload process?
That's an excellent idea. We have nothing to announce today regarding that, but it's definitely something our team has been discussing, and we'd like to pursue it further. Yeah.
Well, that was short, so I'll give you one more. Are there plans to support accessibility automation integration with Google's UI Automator v2?
It's something we're definitely looking at. So UI Automator today uses a lot of the same constructs that we can evaluate. So it's definitely one path to move forward and expand the suite of frameworks that we actually integrate with. But we'll be talking to the Android team about that, definitely.
And thank you.
Great, thanks. I'll get them in.
So with that, I have a few things to say before I send you on your way. I'm going to actually start with an observation. I am trying to decide over today's talks whether I'm on Team Emulator or Team Device. We've seen a little bit of both. We've seen really highly organized Chrome OS labs. We've seen robots that do automation on device for device testing. And we've seen some really awesome expansions on using the emulator. I know that it's sort of a split little question in my office. I see the developers who are writing Google Maps mobile features, like the off-road feature, using their devices all the time for their day in, day out. Just, did that work? Did that work? What did this tweak? Does that actually work correctly? I myself never use a physical device for testing. All of my tests run on emulators. So we're obviously a split office. I'm wondering what you guys are thinking, and I'm hoping that you're forming your own opinions about maybe not is it one or the other, but when do we use each one? When do we use emulators? When do we use devices? And I have to do this because I'm a cheesy daughter. My mom, who is just a few days out of surgery, has been watching the live stream all day, learning all about what I do at Google, because she's also cheesy like that and proud of her daughter. So hi, Mom. And Mom, you're on Team Emulator. And that applause was for you. With that being said, Mom, you're Team Emulator, because that's what I'm currently using, at least. Maybe you'll be a Team Device someday. So now what are we going to do? Well, at 6 o'clock, Google Recruiting has set up the casino night that I mentioned this morning. It will be just upstairs in the common space. There will be a bunch of tabletop casino games. There will be food. There will be drinks. There will be Google recruiters. But it's free. So take that as you will. I also wanted to give a special thanks to somebody who may or may not be in the room. Sonal, who has been our photographer today, also provided us with the awesome Diwali treats for today. So happy Diwali from Sonal, and thank you, Sonal, for the delicious goodies that I hope you all got to take part of. And last but not least, at the end of tomorrow, we're going to have a very long, detailed poll about what can we do better overall at GTAC. But we're going to send you on your way with one small question. What can we do better tomorrow? If there's anything that you think that tonight, those few of us that are on the GTAC planning committee can change so that tomorrow runs more smoothly, please let us know. It's actually the current question available at pollev.com/GTAC2015, where you've been submitting all your other questions. So if you have any comments that you'd really like addressed before tomorrow, let us know there. If they're longer term things that we can't perform miracles and do tonight, wait until the survey comes out after GTAC. And with that, I bid you adieu. You can hang out and congregate down here until they're ready for us upstairs, at which point I think there might be some cowbell. So go have fun, and we'll see you tomorrow.